Recording
Ladies
in
and
progress.
gentlemen, how are you? The lunch was good? Okay? Okay, you can express yourself even in Tunisian if you want. You can tell me it was? No. Okay, so we continue in the same topic, which is capacities for research and innovation. This session called the session 2B, and I invite to come here on the stage Dr. Peggy Oti Boateng, Executive Director of AAS. Please welcome Dr. Peggy Oti Boateng.
Good afternoon again. Thank you all very much. Good afternoon again. Thank you all very much. We've got a number of questions. What does AAS do? And what is the context with this arise? So mine is just a very simple one, to give an overview of what we do. And then my colleague, Obed, will also give you the detail of what ARISE does in the context of all the other things we do as AAS. So without much ado, I'll start with the first slide. Okay. All right. So the first slide is from me, but to know that it is from both of us. All right, okay. So as indicated, I'm going to give an overview of what AAS does. About us, we have a vision of transform life through science. And we want to leverage on science, technology, and innovation for sustainable development. We have 3 tripartite mandates of recognition of excellence, advisory think tank function, and implementation of key STI programs. We are really, truly continental. And as you can see, hopefully I'll be able to use the, good. So, sorry, I hope it's not on people's faces. Okay. We have, 5 vice presidents. One is in Morocco, which is Professor Raja, Morocco representing Northern Africa. Then we also have Professor Okonofoa representing, representing West Africa. Let me go back, sorry. Yeah, representing West Africa. He's based in Nigeria. Then we also have another vice president in Yaoundé, representing Central Africa. Then we have Southern Africa, Professor Ozonama, also representing Southern Africa. Then we have Eastern Africa, Professor Zuma Shabani, representing the Eastern Africa. In addition to that, we have the executives of the governing council, and this is, we pride in this. And this morning we said this is the first woman we have in 40 years. So we really pride in that, to have Professor Liz Costin as our, president. And she is from, Southern Africa, as we indicated this morning. Professor Okonofoa is the Secretary General from Nigeria. Then we have Professor Gong, who just chaired. He is from Eastern Africa, but as one of the mandates being based by the host government in Eastern Africa, the treasurer has to be from Kenya. So we have Prof. Gong and all the other faces that you see here. So more or less, this is the new face of the governing council for the next, 10 years. We also pride in the fact that we have a representative from the African Union. So you can see Professor Kulidati, who is also representing the African Union Commission on Education, Science, Technology, and Innovation, making us really, truly Pan-African. Again, I won't belabor the point that we have 3 tripartite mandate, which hasn't changed over the time. We have run this for the last 5 years. All we have done is to put new focus in the areas that we're working. With the recognition of excellence, which we're talking about, we also award distinguished fellows as members of the academy. So if you're here, and I think you're a distinguished scientist, we invite you to join the African Academy of Sciences, the only continental academy. We also have not only just Africans, but those of you in the diaspora who also work in Africa. We also have Europeans who work in Africa, and also, these are fellows. Then we also have affiliates, program. We run the Obasanjo Prize for Science, Discovery, and Technology. So this is our way of recognizing, excellence. We have founding fellows, and these are, distinguished scientists who in 1985 came together to form the academy. I must say about 30% of them are in heaven, but we still pride in this 34 founding fellows. We have honorary fellows who are all distinguished fellows, and most of them are Nobel laureates, For example, we have Kofi Annan, we have Professor Naledi Pandor, and a host of them who was also honorary fellows. And then we also have fellows and affiliates. And I speak, next month, we're going to call for, membership. And I'll encourage all of you, if you read the criteria and it fits you, please join, because it's an association which I think not only EU has recognized as a strategic partner, but also the AU has recognized as a truly Pan-African, and also the UN, agencies. We have 10 areas which we work in truly science. And I must say, one of the areas that we haven't done very well is in science policy and also engineering. So we want to enhance and increase, that area, because if you're talking about infrastructure development in Africa, we really need the engineers. So we want to beef up, in this, area. So please nominate. If you're a fellow, nominate a fellow. But if you are if you want to be a fellow too, you can also be nominated by fellows to join, the academy in any of the 10, areas. We're also encouraging the diaspora. We're talking about brain gain. Can we have all the people in Africa contributing in other areas, whether Europe, Australia, US, to come back and serve and work in Africa through the program that we have, also recognizing the diaspora. Think tank functions, I've already talked about it. And this think tank function is also being leveraged on by the African Union. As I speak, the African Academy of Sciences is one of the task force members reviewing rewriting the next 10 years of the TISA 2034, as alluded to by my colleague, from NEPAD. So these are all the various areas that we work in. And I must say that one of the critical factors, AAS over the years is that we have provided, access to science. And you can see, most of our Rice Fellows, but my colleague Obed will give you, more detail. We also create an opportunity for adequate stakeholder engagement and buy-in, as we're doing now. And again, what has reoccurred, and the president said it this morning, is that we're looking for a truly equitable partnership around research and innovation. And we pride in the European Union as one of a genuine, partner in all that we do. We also create an enable environment and framework, an instrument, for, science to work for the sustainable development, of Africa. Again, the second area we, also have developed over the years, 40 years, is that we have created sustainable and equitable research and innovation partnership by setting the agenda. For example, setting the agenda with EU, AU, NEPAD, with UNESCO, WMO, and all other partners who come to work to be able to set the agenda. What we're also looking at, and in fact, one of the gaps in the TISA 2024 was that we haven't really accessed innovative financing to be able to implement, the Africa agenda. So one of the areas that we're really looking at, how do we develop innovative financing of research, bringing in partners, private sector, industries, as indicated today, from lab to market. How do we do that? So that's one of the areas that we also, working on. And then we have challenges as well. But what are the challenges that we have? We have competing priorities that restrict or influence fund flow. For example, one of the things we found in Africa, there's too many proliferation of organization. NGO here, NGO there, real big proliferation. Why don't we come together to leverage on our expertise and capabilities and capacities and work together as one Africa, just like we're doing with the EU? Come together. EU has different, they will tell you different divisions, different areas, but they come together with us to leverage on what they do. So, this is what we're calling for, so that we can enhance, fund flow and work together. And we're also looking for global and regional geopolitics has really affected, the way we do science. I don't know whether my colleague from Niger will be happy with that, but here we had a very thriving a Rice Fellow with all the PhDs and all that, but has to slow down because of geopolitics. So again, this has also done. So why don't we enable an environment, peaceful environment, to be able to do the work that we do through science diplomacy, for example, which is what we're pushing. So this is some of the challenges that we have had over time. And then, implementing key science, technology, innovation. This is what we have done very well over the years. AAS mission is to catalyze investment, strategies and programs that promote the brightest mind, like you here in the room, the Rice Fellows, to foster scientific excellence, inspire research leadership, and accelerate innovation. For example, you heard from our colleague, the EU this morning, and also, Auda NEPAD, is that this 10 years is to accelerate science, technology, innovation. We've got all the plans, we've got all the policy. Now is a decade for acceleration. You also heard UNESCO this morning say they also have a decade for science, technology, and innovation. And I'm sure my colleague from UN DESA is here. And also, it's all, we've got it all, but we have to accelerate this. And AAS is one of the organizations in Africa creating, the environment, the convening power, bringing scientists so that we can accelerate the African we want. But not only that, but also the SDGs to be able to accelerate. So we want to shift, the gravity, the center of gravity for Africa science to Africa, for Africa, by Africa, in partnership with all the partners globally. So now we've got a new strategic plan, and we also pride in it, but it's online. The vision remains the same: transform light through science, but we've sharpened, our mission that we want to leverage on science, technology, innovation for sustainable development. And I said this morning that we also want to pursue the values of integrity, which has been really questioned, in Africa over the last 10 years, where donors come, they take our genomics data, they don't accredit anybody. And this morning, it was alluded to, publication, we are not accredited. And then pharmaceutical industries, they take it, they make the drug, they bring it to Africa. It's not equitable. We need to have a win-win collaboration of respect and fairness, of integrity and inclusivity. One of the issues we have in Africa is linguistic diversity. But in this room, we're only speaking English. But we have our French, we have our, our Lusophones. How do we harness that? And also even Arabic. How do we make sure that everybody is inclusive? And this is one of the areas that we're looking at. We also have, a thematic focus, but what we also want, we're pushing for now, is that we want to have result-based management programming. And this also came up in the AU, the TISA 2034, that we didn't have clear-cut monitoring and evaluation to actually assess our progress and put the brake where it is. So this new strategy has that, so that we'll be able to assess, our progress, over the next 5 years, and then also working within the context of the African Union agenda. We also find a lot of opportunities in, fostering partnership with UN agencies, which we haven't done very well over the years. But now you can see in this room, we have a number of UN agencies here because we share in the same, strategies and policies. We have UNESCO, we have WMO, we have UNECA, we have UNDESA, we have International Atomic Energy Agency, and all the others who are pushing for science, technology, and innovation, and also to sharpen, our collaboration with IODA and NEPAD. Impact on climate change is an area that we also find as a big opportunity, and that's why we're working with WMO. We also want to leverage on science, technology, and innovation with SDGs, UNDESA, UNECA, UNESCO, we find those as opportunities. Then we also have young academies. For example, all these young researchers, are Rice Fellows. When they finish, they go. We don't have a pool for them. So what we're doing, we want to catch you early and then also train you and groom you so that you're all potential, fellows, so that we give you an opportunity, work to you together and groom you, as full-fledged fellows. So if you are not yet one of the members of the Young Academy, please assign to that. And you're all potential, all the Arise Fellows, you're all potential Young Academies. Because in Europe, they'll tell you, in China, in Australia, many countries, in the UK, they harness the potential of academies in science, technology, and innovation. We haven't really done well in that in Africa, and we want to use, this platform and also the AAS to be able to do that. Promoting inclusivity, as I've said, engaging, and expertise, but also growing the next generation. Many of us may not be here in the next 10, 15 years, but we have all these under, and we want to capitalize on Africa's demographic dividends, which is many of them, over 60 or 65% of them are under the age of 35. So why don't we harness those potentials? So We also want to grow the next generation. The open science, the director of UNESCO said it, open science, digital transformation. And today, I heard from the question about repository. Do we have a repository of African data and information? We don't have that. Do we have that can we have that through open science and create the opportunity so that scientists can leapfrog and not going anywhere looking for the data or the information? A lot of researchers, and they will attest to that, if they want to do any research, they'll have to go to maybe Europe or, America to be able to find the information because we don't have that. Can we have African Academy of Sciences creating that repository of data and information so that we can leapfrog in our research? And also through promoting of open science, and also addressing economic challenges. And this morning you heard, how do we get, our research to market? So don't do the research for research's sake. You should do the research that will impact. And African Union has got its aspirations. How do we address those? In addition to even the EU or any of the global development agenda. So how do we, foster that? What we haven't also talked much about is urbanization and competitiveness. Now, if you go to Nairobi, you have high rises everywhere. And I'm sorry, many countries are there, but we haven't been able to, put in place all the various infrastructure which goes with urbanization, and also the water, the energy, even the food to feed our people. So that's an area which, maybe we haven't harnessed much on that, but we find this as a big, opportunity to. So working with UN Habitat, UNEP, and also other organizations will be able to leapfrog on that. And then science diplomacy, which I mentioned. The geopolitics of Africa is calling for, science diplomacy. How do we use science, to inform policy for peace, in building peace, on the continent, and resolving, conflicts on the continent, or using it to strengthen partnership? Yes, this was a cliche in Europe. And I'm sure UNESCO also started there, but how can we harness that, so that we can learn from each other and use science based on evidence to build peace in the world? All the geopolitics that are happening, can we, as scientists, come together to provide those evidence, in doing that? Which also borders on science journalism. How many science journalists do we have to really tell the story, of science? So, in a nutshell, this is the overview of the Academy. So we're now hammering, go into detail in, say, how can we use the AAS in catalyzing the Africa's development through research and innovation? So I invite my colleague, Obed, Dr. Giga, to give the rest of it. So thank you very much.
Thank you very much, Dr. Peggy, for the overview. Make my work very easy. I just go talk about one or two things, and then we go to the presentations from our RISE fellows, who are actually the people that have brought us here. As the ED said, we are working in concert with the African Union, inspired by the aspirations of Africa Union Agenda 2063. We have a blueprint in terms of where we want to go as a continent, and we are privileged as the Academy to be partnering with colleagues like the African Union Commission or AUDA-NEPAD, the European Commission, and other partners to try and advance Africa's research and innovation agenda, even as we drive development on the continent. So research for development is what we're trying to contribute to as the African Academy of Sciences. And so we've gathered here in Tunisia to celebrate what we've been able to do through the ARISE program over the last 2-3 years. The idea is we're supposed to help facilitate the generation of the science that we need to inform our development priorities as a continent. And we'll be hearing from our researchers in terms of the work that they do, but how that work contributes to the discussions we're having around Africa's research and innovation agenda. So our programming in general, I'm privileged to be part of a team at the Academy that is implementing various programs in support of our vision as the Academy, but also in terms of how that contributes to the transformation of life in Africa through science. And our programming is themed around 4 areas, the first of which is really strengthening research and development leadership, but also environments. We want to create enabling environments, enabling ecosystems that support the generation and the use of research and innovation on the continent. And as we do this, we are trying to push the research to get out of our institutions of higher learning to transition to market. So that translation to innovative products that begin to address some of our developmental priorities and challenges is very critical in the work that we do. And even as we do this, as we aim towards 2063, and we know that we must have a critical mass of scientific leaders that would actually help us deliver the Africa we want. And these are the ARISE fellows that you see in the room today, among other peers in Africa, across Africa, that are working towards building that research capacity that we want. Unfortunately, Africa is still struggling with research inequality, research capacity inequalities. Some countries are doing better than others, and you'll be hearing throughout the discussions over the week in terms of what we can do to minimize those inequalities and make sure we don't leave anyone behind. And so the African Academy of Sciences is also investing in that space to try and fill critical gaps in research so that then our researchers have an enabling environment to thrive in the work that they do. And we don't do this alone. We thrive in partnerships, and as has been highlighted by the ED. And over the years, we've been able to partner with colleagues and partners to implement various programs. But for the purpose of this meeting, I'll just focus on ARISE. And just to mention that in 2015, through the African Union Heads of Summit resolution, the African Academy of Sciences, together with AUDA NEPAD, came together to create a platform, to create an arrangement where resources could be mobilized to try and address Africa's research and innovation priorities. And this is in contribution to Africa's Agenda 2063, as Madam Peggy mentioned. So over this time, we've done quite some work. In fact, just to give you a sneak preview of what we've been able to do since 2018, effectively aligning to our immediate previous strategic plan, we've been able to mobilize more than $200 million during that time, more than 75% of which has gone directly to the researchers themselves. And during that period, we've supported more than 200 principal investigators and implemented various programs, supported a number of early career researchers, mid-career researchers, advanced level scholars or researchers, if you may, that have continuously over this time contributed to our development as a continent. And we are producing a report. It's in the kitchen. It's being cooked. In the next few weeks, we'll be having a report that gives a snap overview of the work that we've done and what begins to look like the impact of the investment that has been made over these years. And so that when ARISE came to the Academy, it found already an established model of funding, initially targeting early career researchers. And you'll see that ARISE is actually co-funded by Carnegie Corporation of New York, because in 2017, they gave us a seed grant to test what has now become the ARISE model that we have today. Of course, it's grown inspired by the ERC, the European Research Council grants, and it's grown bigger in terms of the scope. But the idea is through this kind of partnerships, we are able to leverage our resources, whether internally at the AS, but resources of our networks and partners to deliver a product that is ARISE today. And the good news is, inshallah, in the next few weeks, I'm being ambitious right now, but in the next few months, God willing, as we get into next year, we will see ARISE grow into a full program that then begins to address more serious scientific questions across the continent, not just targeting early career researchers, but working with those that are in the middle career, but also advanced or established scholars, so that we can collectively and holistically begin to address our research and innovation priorities. So just a sneak preview of the grantees or the ARISE, the current pilot program. And I know there was a question in the morning talking about, do we have a repository of what ARISE has already done over the last couple of years, so that then we can leverage on that even as we move to the next steps. And I will invite the person who asked that question to listen to the presentations from our ARISE fellows. And at the end, then you will tell us if you like what you see. And I can promise you, having the privilege of interacting with these grantees, that they are brilliant minds, lots of promising results. What even begins to look like impact 2 years just, after the beginning of the fellowships. And I know that you'll be thoroughly encouraged what we hear from the presenters of ARISE. So currently we have a pilot, 25.5 million, which funds 47 principal investigators located in 38 countries today. And these principal investigators are supporting master's students, PhD students, postdocs, a number of which are actually here in this meeting today. So as you interact with the scholars in the room, you get to meet them. But at the end of the 5-year fellowship, we're expecting to support at least 500 researchers that have directly benefited from this arrangement. So it has a huge cascading effect. And like I said, and you'll agree with me when you begin to listen to the presentations, that this program is already having an impact on the continent. And so that's more or less a map that gives an idea of where we are. We have a few countries left, but in the next phase, God willing, we want to cover the entire continent so that we don't leave anyone behind. Some of the early results, I'll not belabor the point. I'll let the grantees, through their presentations, get to show what has already been done. And I'll not talk about what we do, but generally speaking, key results areas, the ED talked about result-based management and accountability of the work that we do. We want to, at the end of this process, get to map how much value we bring out of €1 invested into this program. And we think so far that what we are seeing is very promising. We'll continue to monitor this and report as we proceed. So a snapshot of what we expect in terms of the full program. We have a very ambitious program. We actually are trying to grow this into at least 200 million grant in the next few short months. And with the partners that we have in the room, we'll be reaching out, if we haven't already, so that you help us with ideas in terms of how we get to the 200 million. We believe that this will help us begin to achieve the impact that we want to see on the ground, and leveraging on the success of the current pilot program, together with the partnerships that we've created with everyone in the room. We believe that this is a small target and we'll be able to get to this. And of course, we are very grateful for the massive investment from the European Union. Have believed in our story, worked with us over the last few years, and we are looking forward to a continued partnerships as we grow into that space. So we, like I said, the current pilot focuses mainly on early to mid-career researchers, but we want to grow that envelope to begin to target people that are somewhere in the middle of their careers, as well as the advanced scholars. So we are very much inspired by the European Research Council grants, as you would see. In fact, it's not, as Professor Maria Lepton mentioned in the morning, the former president of ERC, Professor Jean-Pierre Bourguignon, is one of the scientific advisory members of ARISE. We're also benefiting from the leadership of people like Professor Jean-Paul Moati, the former president, together with distinguished scholars that form part of the scientific advisory committee and technical panel members of ARISE. So that, again, the program is in very good hands, and thanks to the leadership of the SAC and Strategic Steering Committee, together with the leadership of the heirs, we believe that we have what it takes to actually deliver ARISE as a full program in the next few short years. So I'll stop at this, but invite everyone to partner with us. There's everyone gets something at the heirs. If you're not a fellow of the academy, you can be an affiliate. If you're not an affiliate, you can be a grantee. If not, you can join us as a funder or a collaborator, a reviewer for some of the grants that we send out, but also as a co-implementer. We can partner for the work that we want to do going forward together. So for the interest of time, I'll stop here, and thank you once again for creating time to be here with us, and wishing you a very successful engagement in the next few days. So now I hand over to our moderator to bring the next speaker. Thank you.
Thank you. Thank you, Dr. Obed-Ogega, for these positive vibes and this beautiful speech. Thank you, Dr. Peggy Oti-Boateng. And now I invite Mr. Jean-Michel Serre, General Director of ENTPA, European Commission.
Wow. After two such great speakers, I'm very under pressure to close these opening remarks and let grantees start presenting their work to the audience. But it's important that I want to pass some key messages from my service at the European Commission. You know that I work for the Department of International Partnerships in the European Commission in Brussels, and this is the department overseeing the implementation of RISE on the EC side, together with colleagues from DG RTD. But first and foremost, what I would like to share with you is a testimonial with you from a RISE grantee with whom I spent some time in Brussels when he attended our big education forum 2 months ago. We spent some time, and I just asked a simple question to this researcher. I asked him, what has RISE changed for you in your career and your personal life? I don't tell you who he is, but he's among us in this room. And I think what he said to me, most of the grantees could have said the same. He said to me, the RISE project came at a crucial moment in my career because it enabled me to lay a solid foundation for our young laboratory in terms of equipment acquisition. He also said to me, RISE made a significant contribution to field data collection, especially in remote areas, probably something he couldn't afford before. He said also, RISE enabled me to contribute to the capacity building of our technical staff in our younger team and permit the acquisition of new tools. And finally, he said, I'm not able to carry out my scientific research on site and put my exercise to good use, but thanks to RISE, I managed to do so and reach that ambition. So all this sum up the program's ambition when it was designed years ago. I wasn't there, but some of you were at the very start of the program. Our ambition at that time was to equip young talents with the means to succeed, to help make the African research institutions more attractive and researchers less vulnerable to brain drain. And I think we more or less agree on the relevance of these objectives and some success in that field. So we earmarked 25 million in funding to support the researchers from as many African countries as possible on the continent, and the facts have proved us right because it's the countries are well represented in the panel. This is borne out by an evaluation we recently launched to assess the impact of the program as we approach the midterm of implementation. And key findings of these evaluations are that RISE aligns with the African Union, European Union strategic priorities, addressing critical research and development gaps, while strategically contributing to pertinent sustainable development goals, thereby reinforcing the synergy between policy objectives and practical research initiatives with Africa. That was the first good statement from the evaluation. The evaluation also concluded that ARISE addressed some of the challenges within the African research and innovation landscape, offering solutions like robust financial backing and long-term support, directly impacting the research environment and capacities. The evaluation also underlined that the program empowers researchers by providing substantial resources, extended research timelines, and capacity building opportunities, mitigating brain drain, and fostering an environment conducive to scientific innovation and independence. I could get more in depth in what the study says. I will stop here. Just know that we are considering, of course, the result of this evaluation for the follow-up of this ARISE pilot initiative. I will conclude by saying that ARISE would not be a reality without the commitment and experience of the African Academy of Sciences that I salute here in the name of the Commission. We would also like to thank very much the host of this great conference, because this is a beautiful place, and I think we all enjoyed being here. And I'm sure we are all looking forward to hearing more about our distinguished scientists. The ARISE pilot program is there for them to have their ideas and talents recognized and developed further. Thank you very much, and enjoy the conference.
Thank you, Mr. Jean-Michel Serre. Thank you very much. And now we are going to the part one of a kind of panel. It's about research spotlight presentations. So we have research spotlight presentations with the moderator, Professor Hamisi Malebo, from the National Commission for UNESCO from Tanzania. Please welcome Professor Hamisi Malebo. And Mr. Hamisi Malebo will invite after me the two rapporteurs. You call them or I call them?
You call them.
I call them. Okay. Now or after your speech?
No,
now?
you call them now.
Okay. So I invite Miss Ons Masmoudi. Yeah. So rapporteurs stay at their tables, but we invite the other persons who are...
Yeah, the presenters.
Yeah, the presenters. Okay, I invite them. So, the first one is Dr. Mohammed T. Rouabah from the University of Constantine. Thank you very much. The second is Dr. Katawura Beltako from Université de Lomé, Togo. So the third person is Dr. Hafiz Yusuf Hafiz from the Federal University Dutsi from Nigeria. And the fourth person is Dr. Hobi Raza Findrakoto, Institut et Observatoire de Géophysique d'Antananarivo from Madagascar. So I let you with those four personalities.
Yeah. Thank you very much, ladies and gentlemen. Now we have come to an interesting session. In the morning, we have been discussing about the general aspects of science. Now we are coming to the specifics. In front of you, we have the ARISE Fellows, who have done quite a number of research undertakings. And in this time, they are going to exemplify the impact of the ARISE program and what has been happening across Africa. As I've been introduced, I'm Professor Hamis Malebo, the Secretary General of UNESCO National Commission of the United Republic of Tanzania. By training, I'm a medicinal phytochemist, and briefly, during the COVID pandemic across the world, I innovated and developed the COVID herbal medicinal remedy, which was widely used in Tanzania and saved a lot of lives. And also, I innovated on a herbal inhalable product, which was also useful in mitigating against the respiratory conditions associated with the COVID-19 in Tanzania. As ARISE extend innovations through supporting fellows in Africa, I would like to take this opportunity to invite the first presenter, Dr. Mohamed Roba. Dr. Mohamed will be presenting on light scattering, quantum information, and quantum simulation by cold atoms. So, Dr. Mohamed, the floor is yours now. You are welcome.
Thank you for the introduction. Good afternoon. Somehow Jean-Michel spoiled my introduction because I wanted to start saying that the RISE grant was a turning point of my career because it allowed me to take a big step forward that I have been preparing for since the beginning of my academic journey. And in this presentation, that is entitled Building Africa's Quantum Expertise for Global Impact, I will give you an overview on the work we are doing within our research group under the RISE grant. My name is Mohamed Tahar Wabah. I'm Associate Professor at University of Constantine I in Algeria and Principal Investigator of Constantine Quantum Technologies, a young research group supported by the ARISE program. And I will give you an overview of our work and how we are aiming to be a serious player, at least, in this game-changing technology. So the computational demand of AI, quantum chemistry, material science, and logistics are exceeding the capacities of our supercomputers and nearing theoretical limits. Moore's law is dictating that the number of transistors on our computer chips will double every 2 years. However, with silicon chips already scaling down to nanometer scale with few atoms, they cannot shrink much farther. Hopefully, quantum and quantum physics is opening new horizons. The laws of quantum computing, of the laws of quantum physics, is giving more perspective to much more power. Classical computers leverage binary data sets to make computation, and those sets of data can have only one of two defined values at the time. Quantum mechanics allows quantum computers to use qubits to process information, and those qubits can have two values at the same time. then 1 qubit can represent much far and much more values than their classical counterparts, which are bits, enabling a much more power and much faster parallel computation with a lot of applications in enhancing AI for many applications, because the qubits can have 2 values at the same time. So quantum computing has the potential to enhance deep learning and AI with much and provide much more computational power with exciting applications in many different fields related to chemistry, medicine, climate change, agriculture, and even logistics and finance. So today, it's still very challenging to build fault-tolerant or useful or efficient quantum computer because of the large amount of very advanced technology combination required to build big quantum computer with a large number of qubits and low error rate that might be able to realize spectacular breakthroughs like breaking encryption codes or simplifying very complicated calculation from thousands of years to milliseconds. However, nowadays quantum computers, even though they are noisy, they are faulty, but they might be used for some specific use cases. The ARISE grant allowed us to modify our research focus from previously being oriented toward theoretical studies of hypothetical quantum computers toward the focus on developing quantum computing and quantum coding, quantum programming skills and competences to create quantum algorithms that might be used and applied on nowadays quantum computers, also known as NISQ-era quantum computers. So 2 years ago, after the award of the ARISE grant, we started building, we created Constantine Quantum Technologies, and we started building not only a team, but also a brand with values, history, and also a reputation through a very wide and very a great communication, networking, and education effort that we have been deploying since the beginning of the grant. Under CQTech and ARISE Benin, we have presented 15 presentations in local events, more than 16 talks and posters in international conferences. Our students participated in 4 high-level summer and winter schools on quantum computing. We organized 3 local training on quantum computing in the country, and we ensured more than 20 hours of mentorship sessions in high-level quantum computing international programs. Our team members earned more than 50 quantum computer-related certificates in 2 years. We have participated in 8 hackathons, and we won 5 prizes. 3 of them was first prizes in high-level international hackathons. On the top of that, we have been working since more than a year now with many quantum leader, African quantum leader working in Africa and abroad on the creation of the African Quantum Consortium. CQTech is a founding member, and they have been appointed interim vice president of the consortium since June 2023. So thanks to CQTech, we are now, thanks to CQTech and ARISE, we are now not only focusing on topological quantum computing that has been our field of expertise before the grant, but now we are also building and designing quantum algorithms that are usable and applicable on nowadays quantum computer. In one of those projects ongoing in CQTech, we are studying a system of fermions, which are electron-like particles, which are arranged in kind of shape that is called Kagome lattice. Without going into deep details, this kind of shape with this kind of arrangement has a direct application and a very hot topic in material science for the exploration of new exotic phase of matter called the topological phase of matter. We have designed the quantum algorithm that we have run on real quantum IBM devices, and the preliminary result that we have presented recently in a research collaboration group in US have attracted a lot of attention. On another project, we are also developing quantum algorithms for quantum chemistry to study and investigate the energy spectrum of small molecules. In this paper, we have been working in collaboration with chemistry engineers from NASA, from Purdue, Ohio, and Columbia universities in US to simulate and study H2 and H3 molecules on real quantum computers. I'm putting this here not to advertise the paper, but just to say that what allowed us to be part of such extremely high-level publication is the fact that we have been able to talk to these quantum or to these chemistry engineers, understand their problem, have a look on their codes, correct inaccuracies and errors in their codes, create from scratch a quantum algorithms to solve their problem, and apply that quantum algorithm on real IBM state-of-the-art, best of its kind quantum computer in the world. And this is a skill by itself, which is missing even at such high-level institution. We are also on another project trying to understand and investigate the properties of beryllium hydroxide, which is a larger molecule. And the aim behind those studies is to prepare the tools, competences, and algorithms for the investigation of larger molecules with an accuracy which is enrichable with AI and classical computers. The application of such investigation with such accuracy will range a large spectrum going from all or applied to all chemistry-related fields, from healthcare to climate change to agriculture, etc. Thanks to the visibility we got from our network and from our participation and prizes in the hackathons, we have been reached by a big multinational consultancy company from US, and they asked us to design for them a quantum algorithm to optimize the inventory system in big automated warehouses like those used by Alibaba or Amazon, etc. During 3 months, last summer, we have designed an optimization algorithm from scratch that have been applied on a Canada-based quantum computer to optimize the trajectory of the shelf carrier robots in this image, and for us to ensure that the robots would have the smallest distance possible. Optimizing that distance have a direct impact on gaining time and less maintenance price and less energy consumption. Beside the state-of-the-art classical optimizer, our algorithm developed within CQTech have beat all the classical algorithms widely used for optimization. And this is despite the early stage of the technology and the very limited access we got to the quantum computer. We got 1 minute per month access to the quantum computer, and we have already been able to achieve such an advantage. On another application of quantum computation for another field, CQTech is developing quantum machine learning technique for green energy transition. This project is still in stealth mode, and all I can say about it is that we are collaborating with geoscientists within an incubation program in North America for us to develop quantum machine learning techniques to be applied in mining companies to ensure cleaner mining exploitation and more accurate mining accuracy. So far, the techniques developed within our group have attracted a lot of attention from from several investors around the world. As conclusion, I would say that the relevant takeaway here is that we are developing a very valuable transversal competence within our group on cutting-edge technology, which can be applied to a large number of transversals, going from healthcare, agriculture, material science, data encryption, logistics, energy, and finance. At the end, I want to close with this quote, saying that the 19th century was known as the machine age, the 20th century as the information age, and many of us believe that the 21st century is going to be the quantum age. Within CQTech, alongside with many African quantum leaders, we are doing our best to ensure that Africa will not miss this century train as we did with many others. Thank you very much.
Take your seat. Thank you, Professor Mohammed, for the good presentation. Please keep your questions to the end so that we will ask presenters during the question and answer session. Professor Mohammed have presented an interesting topic on quantum science, and Africa is really not left behind on quantum science, as you can see from his presentation. I would like you also to take this opportunity to invite the second presenter, Dr. Katoura Beltako, from the University of Lome, Togo, will also present on quantum simulations and energy materials. Dr. Kataura, the floor is now yours. You're welcome.
Thank you so much. Okay, good afternoon, everyone. I would like to start by thanking the AES for organizing this event, and thanking the ARISE team and the partners from European Union, African Union, and thanking our colleague, Dr. Emna, for holding all this event as well. So you heard a lot of quantum today, right? So we'll continue again. Quantum emotion. Yes, because it's one of the field where we don't want Africa to be left behind. This is why we are pushing you with quantum and quantum again. But let me start by just, should I push one? Okay. It's not moving.
Quantum is failing.
Or should I use
Yeah, it's okay.
here?
No, it's okay.
Okay. Yes, so my name is Beltako Kataura, and I will be presenting on quantum simulation and energy materials. I'm a researcher from University of Lome in Togo, is a very small country close to Ghana, if you don't know. So let me give you a few very quick hints about quantum, as we are talking a lot about quantum. So, no, let's go this side. So what is quantum about? So quantum is just this I show here. So you can see what we deal with in quantum world is just some kind of particles that are very small. And then main of their property is that they can be everywhere at the same time. They can be everywhere at the same time. And then if you try to look at them, then they show up at a very single position. And the next thing about them is that no mountain can resist them. They can cross mountain just by tunneling through it. And the other thing is that they can be simultaneously alive and dead. This is the story behind quantum. So now you know 3 basic principles of quantum mechanics. It's very easy, right? So this is what quantum mechanics stand for. Like, this is 3 of the principles of quantum mechanics. And you have to say, maybe you are asking what this have to do with what I'm doing right now. So when you look at materials, when you take a mineral, for instance, like the one on the left, you say, okay, this is just a mineral, but then when you cut it into small pieces, you end up with something like the picture on the right side, and you see that the material, every material have a very ordered structure inside itself. So you can extract a very small part of it, like the very basic units that form this mineral or the material. This is like the DNA in a body for those that are in health. So this is the thing that we study. So we study the basic components of the material or the mineral, you know. So why do we call this like quantum material? Because they don't behave like normal material. Like when you take your mineral, the laws you use to study it is different from the laws you use to study these materials. And these laws are what I said before. So basically, our project actually enter into the SDG goals, and it's about climate actions and affordable clean energy actions that we try to achieve through this project. And the main fields, or actually the main topics that should be looked at are photovoltaics or renewable energies, but we have new directions on fuel, clean fuel, and hydrogen production, electrolyzer, and so on. But our research project actually aim to develop new materials, to look into these materials that will help us to get into clean energy access or low power power consuming electronics. This is the aim of our project. And then from there, we want to do technology transfer and trainings as well, supporting innovation in that direction. So these are the goals of our project that is called Quantumarize. Then how do we do it? We do it through algorithms. We write codes, like he said, but he writes quantum algorithms. We use normal classical algorithms with quantum mechanics law. It's different than to predict properties of materials and then to improve the electronics we are using. Our workhorse is HPC computers. So we need a very huge facility with computers. These are pictures of few of my PhD student, the PhD student working with me in my lab, through ARISE grant, of course. So few points, I want to point out few of the things we were able to achieve through this grant, actually, is that we were trying to screen one of the type of materials that's called perovskites. And we tried to, this is a kind of material where people try to use it as a replacement for silicon in your solar cell systems or different kind of devices, but we focus on solar cell development, and we were able to propose few of these materials, and one of them were able to achieve as a device solar cell up to 32% of efficiency, which is something maybe might not speak to you, but in fact, if you look at your solar cell, home use solar cells, they are at 20 or 25% maximum. So in theory, people predicted up to 28%, 30%, and we were able to propose something far beyond this, that would be 32%. And from that on, we are trying with our colleagues from University of Bratislava in Romania to try to synthesize and check if this is actually stable, and so on and so on. The next point is achieving predictability. So predicting, like having materials, and then you want to predict or use it for solar cell or something else. It takes time. So we go through machine learning as well. We develop AI tools, pipelines, that will help us to screen all the databases, existing databases in the literature. And then from there, we can just check for specific properties. And then if the material, for instance, match specific properties, then we can extract these data and then come up with a model that will be able to predict. We don't even need to pay a huge equipment to try to check material one by one, but we just develop the pipeline that will help us to quickly screen and then target the very specific material that will be really good for a very specific application like solar cells, as we are looking at here. Other materials that we looked at are actually two-dimensional materials. A simple example of two-dimensional materials is your pencil, graphite, from your pencil. You can easily extract a two-dimensional material from your pencil. So this is something very easy, but it's one of the most resistant materials that is even stronger than steel, right? Stronger than steel. I don't know whether it's steel or... Yeah, so this material is very resistant, but also show very good properties that are interesting for solar application. So currently, through ARISE grant, we're able to propose 3 new materials. And these 3 materials, with our colleagues from Aix-Marseille University, we are trying to investigate their capability as a heterostructure added with others to be able to apply them in solar cells. And currently, one of our students is in mobility at Marseille for that. So these are very quick 3 short points on what we do, or few things we were able to achieve. But then beyond the scientific, we try to support the community. Because one thing we noticed when I started the grant was that I couldn't hire people I needed, I couldn't find them. The skills were missing. So what I did is to try to implement a kind of training every year that will be able to close the digital gap. Basically, the skills we need, we implement them in these trainings so that this young generation coming up will be a seed for us for next calls for ARISE or these things. And other thing is that we try to check, for instance, how the use of batteries in what is the life cycle, what people do with that. Is this recycled well, and so on. And so there are these few projects that we try to do as support to our community at the ground. And then for our institution, the University of Lomé, so basically there are strong impact over there because the project is implemented over there. And the strength, we are strengthening the research on the ground because this group of research units is something new because there was nothing like that before. And then all the equipment also is in kind of reinforcement of the facilities in the university. And the technology transfer, everything that will be a technology will be transferred also to the university, and we support the excellence centers that are already on the ground. And with ARISE, we are planning to get a very specific and unique compute cluster that is actually something that will be unique, kind of unique in our in Togo, for instance. So to sum up, the take-home message is that this ARISE grant helped us to support at least more than 10 students and currently, and we have several researchers involved from the university and admin staff, and we developed impacts on our community by doing training, also helping through our community problems like recycling materials. So currently we develop also collaboration. These collaborations help our students to move around and gain experience from elsewhere, but also to do the experimental part of our work. Thank you so much for your attention.
Yeah, ladies and gentlemen, the second presentation was also in the area of quantum science. Now we are moving further, still in the same direction, but now we are moving to the development of efficient and robust mixing-based photocatalysts for production of solar fuel, which is hydrogen, via photocatalytic water splitting. This will be presented by Dr. Hafiz Yusuf Hafiz from the Federal University, those from Nigeria. Dr. Hafiz, you are welcome. Now the floor is yours.
Yeah. 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 Chairperson, respected colleague, good afternoon. My name is Dr. Hafiz Yusuf Hafiz from Federal University, Nigeria. I'm currently working on solar fuel hydrogen generation via photocatalytic water splitting. Before I start the presentation, I would like to extend my gratitude and appreciation to the members of the AIS, ARISE team, and the local organizing committee to this wonderful occasion that I'm attending here before. Now here, I would like to start with the solar fuel hydrogen generation, because as we know that the world is now currently consuming a lot of the energy. If you look at it, you can see that the world is now consuming nearly 2.2 terawatt of the energy and expected to be around 50% by 2050. As such, we need to find an alternative source of energy apart from the one we are using now, conventional one. Fossil fuel remain the conventional main source of the energy, where we are using the oil, natural gas, and those fossil fuel have many effects. Especially, we know that they are finite and they are bringing the global warming, as well as they are depleted rapidly. As such, that fossil fuel we have been using has so many environmental effects. In fact, we have the climate change, acid rain, and air pollution. As such, we need to find an alternative sources of energy apart from the fossil fuel that we have been dependent. Why do we need to find the alternative source of the energy? One reason is because there is high increase of the energy demand. Another one because we have the environmental impact, especially in terms of the global warming, and we are running out of the fossil fuel. As time goes on, we will find out that we don't have even the oil or petroleum we depend on. Now, if you can see on this figure, you can see that the production, the demand is increasing while the production is decreasing. As such, we need to find an alternative source of the energy apart from the fossil fuel that we depend on. Now, hydrogen is considered as an ideal fuel for the future. Why hydrogen is considered as an ideal fuel for the future? One, because it's clean, it doesn't bring any global warming, and another thing is it has a environmental friendly, it doesn't have any issue. Then there is many reasons for why hydrogen is being considered as an ideal fuel for the future. One is that it has the energy security, it has the high combustion and zero emission, meaning that we are not emitting anything that is harmful to us. And the hydrogen is the only fuel that has the highest energy content compared to other fuel. If you compare hydrogen and petroleum, you will see that hydrogen is having 142 megajoule per every 1 kg. When you compare it with the petroleum is having around 42 megajoule per kg, meaning that hydrogen is 3 times than the conventional petroleum we are using. Now, there are several methods on generating hydrogen. Now, on this, we have the electrocatalytic and photocatalytic and thermal process, but in our own research, we are now on the photocatalytic process. Under photocatalytic process, there is photocatalytic water splitting, photoelectrochemical, as well as the photobiological. Our research aims at only photocatalytic water splitting in order to generate the hydrogen. Now, not all the material can be used to generate hydrogen. There are certain criteria for any material that can be used to generate the hydrogen. Those are the few criteria for any material to be used for hydrogen generation. The material has to satisfy the following condition. One, the band gap of that material, it should be above 1.23, and the condensation band must be more negative, while the balance band should be a positive. Then there were many challenges in this process for generating hydrogen using photocatalytic water splitting. One of the problems of this approach is that there is high recombination between electron and hole. Then other one, there is poor separation and migration of those electron and hole. Similarly, some material were unable to harness the visible light. As such, this research is basically based on the MZN-based material, because MZN is a new material that has been developed around 2011 by Yuri, and this material is a two-dimensional inorganic material which consists of the transitional carbon nitride, and carbonide material that can be used in material science for many reasons. And one of the reasons also we choose this MZN because it had the high electron mobility, high thermal conductivity, and high surface area that can boost the hydrogen generation by our material. Here are some of the chemicals we use in order to synthesize our material and the characterization taken in order to study the behavior of those materials as well. Then here is the setup that we are using in order to generate the hydrogen production, where we shine the light, then we put it on the gas chromatography in order to detect the amount of the hydrogen generated by that material. Here, let me start with one of the papers that we published in this year. The paper is on synergistic hydrogen utilization of the magnetic hydrogen production. And this paper, we have been able to use the therapeutic carbon nitride as the base material. That therapeutic carbon nitride had many lapses because the band gap of the material, we need to, it has many advantages for photocatalytic water splitting. The band gap is suitable at low cost and easy synthesis. However, it has so many shortcomings because it has a high recombination, as I mentioned earlier, and also it has low surface area. By combining that graphite carbon nitride with the nickel pyrite, it had the low bang gap and it had the magnetic retrieval, when we combine the two, the photocatalytic hydrogen production activity enhanced, as we can see in the subsequent slide. If you look at this, we can be able to show that single graphite carbon nitride exhibit the hydrogen production of 150, while that of the nickel alone exhibit 60. When we combine the two, we have around 3,400. But when we couple it with also in graphene, a tied material, we can achieve the maximum of 11,000. This is the highest hydrogen production achieved using the graphite carbon nitride as the base material when we compare it with the existing literature. Also, I would like to mention that the achievement we have made so far based on this arrays, because this arrays has already helped us in order to grow. Here is the overall scientific achievement of mine, as you can see. Then also, under the achievement that we achieve under the ARISE, we are being able to publish nearly 10 papers, which some if not all are in Q1 with high impact factor, 7, 6, and so. Therefore, we have really achieved a lot with this ARISE project. Also, through this ARISE project, we are able to collaborate with our research partner in Germany in a Lebanese Institute of Catalysis, as well as the Technical University Munich. Through the ARISE, we have been there, and we conduct a lot of the research, which we are about to publish it soon in the High Impact Factor Journal. Also, through the ARISE, we were able to construct our first laboratory through the ARISE funding, and this laboratory has been named as the Advanced Nanotechnology and Computational Physics Laboratory, which is being sponsored or secured by this ARISE team. Therefore, in terms of the capacity building, this ARISE team has already helped us and helped our country, Nigeria, as well. Here are the few of the research grants the principal investigator obtained in his career. Also, while we construct our laboratory, we name it to be Advanced Nanotechnology and Computational Physics Laboratory, comprised of the 4 members of this one. We have the PhD students that are working in these laboratories. Nearly 6 of them are working under the ARISE. Some of them are fully funded, some are partially funded because they have the interest on the topic. We have nearly 7 PhD students that are working on this aspect. Also, we have nearly 4 MSc students that are also working on this aspect of this research grant ARISE. Such, without taking most of your time, I would like to acknowledge the effort from my Vice Chancellor in person of Professor Abdulkarim Sabu Mohammed, Federal University Dusari, and the members of the AS and the African ARISE, and the members of my laboratory, Advanced Nanotechnology and Computational Physics Laboratory, and all the staff of my department and the tertiary institution of my country, as well as the members of organizing a local organizing committee of this event, especially Emna, for making me to come to this event, because I have suffered a lot. I got my visa at the last hours of the day. Thank you very much.
Yeah, ladies and gentlemen, I think everybody is seeing that African scientists can do a lot if they are given enabling environment and empowered. We are continuing with our presentation. Now we are turning to earthquake monitoring and hazard evaluation in Madagascar. This will be presented by Dr. Hobby Lazafindrakoto from the Institute on Observatory of Geophysics in Antananarivo, Madagascar. Dr. Hobby, the floor is now Viewers, you are welcome.
Thank you. How does this work?
It works.
But it's not full screen. Can you make full screen? Okay. Thank you very much. My name is, good afternoon everyone, and my name is Ubra Zafrakut, and I'm among the RISE fellow, and my project is about earthquake monitoring and hazard evaluation in Madagascar. And it has three main pillars, which is a technology platform, science and research, and capacity building. But today I'm going to focus on the technology platform. So imagine that you are in a concert and try to record the performance. And while you were recording, some of the audience is shouting. So in this way, you have the recording of both events within your record. Likewise, for our earthquake recording, it records not only natural earthquake, but also human activities, events from human activities. Therefore, without a consistent way to distinguish those events, our earthquake source will be contaminated, and that will give a problem for our hazard assessment. And for Madagascar in particular, we have a number of mining activities, and that will implies the potential of mining events. So the aim of this particular study that I will show you is to discriminate between human-made and natural earthquake. And we use machine learning technique to achieve this goal, and which is particularly used for image and speech recognition. And VID is basically to transform this high-dimensional image into small dimension, and that will allow us later to classify whether it's a dog or a frog or a cat. And we use earthquake data to achieve this study, and in particular we use these signals, and we transform it into this kind of image, which are like a frequency time data, and then we have, for instance, this signature from query blast or earthquake. And then we need to train the model, and later we need to do the prediction. And these are the data that we use. For instance, those are non-query blast, and those are non-earthquake. And the data are particularly from, let's say, historical activity, and or from non-signature of mining blast, or event that occur at, let's say, systematic time. And then at the end, we need to test the model. And at the end, basically, we have those either it's earthquake or mining blast. And then we somehow validate our data, our result through, let's say, remote sensing data, or checking the local site. So in this particular analysis, we found that the result that we have even not using in the training, we were able to obtain, for instance, this kind of cluster, and those are particularly in, for instance, in chromium, let's say, mining sites that are particularly important. And this kind of, let's say, classification are in fact part of the machine learning-based earthquake monitoring that we are currently developing. And for the ARISE project, we were able, for instance, the next plan is to install some of seismic station around the mining site in order to have a closer look to the different events. And this has a particularly implication to improve the seismic hazard in Madagascar, but also to have implication in mining control, because for instance, in the area that I showed to you earlier, the mining site was closed for a number of years, and now it has reopened in 2015, and we clearly see that here. So first, I would like to thank, let's say, European Union for the financial to finance this project, and currently we are working also on improving. We are also working in terms of science for all the key elements for the seismic hazard analysis. With that, I thank you very much for your attention.
Yeah, thank you, presenters. Ladies and gentlemen, I hope we have enjoyed listening to great African scientists, and they're doing great. Thanks to ARISE support. And now, in the interest of time, we will ask 3 questions to each presenter in the following order. I will mention the name of the presenter and the topic you presented, and then we will take the first 3 questions. Then we will move to the next presenter to the end. Then they will respond. If there could be time, which actually time is not in our favor, it is not possible to take the second set of questions. Quickly, let's start with the presentation by Dr. Mohamed Rouba, who presented on light scattering, quantum information, and the quantum simulation by cold atoms. 3 quick questions. Yes?
Very impressive talks in this session. My question goes to Mohamed. I just want to know, Amir, do you have an IP protection plan for your very good technology, especially for the companies that are investing in your technology? IP? Have
IP
you done any
protection.
patent for your technology or things like
Okay.
that?
We take three and then you respond, and then we move to a second presenter. First question on IP protection. Next.
Can I take the second one? This
Yeah.
is in regard to Mohammed again.
Your name, please?
I'm called David Onyango. My concern in regard to Mohammed's presentation is in the aspect of collaboration, because it appears as if most of Mohammed's work is not being done within Africa continent per se, but the work is mostly being done within Western countries. And our key aspect of ARISE is to ensure that the researchers are doing their work within Africa. So is it that this grant that has been given to Mohammed was just an addition to what is already going on within his country? And then the second aspect of that question is in regard to what is the product? What is the product per se that Mohammed has come up with? Because my little understanding of quantum physics or quantum chemistry is something to do with the aspect of energy. And so I was expecting to see or to hear that maybe they've got a chip, like the one that we use in telephones, yeah, something like that, that is being used in those aspects of computing and something like that. So those are my two concerns in regard to Mohammed's presentation. Thank you.
Okay, thank you. So, Mohammed, you have received the second question with two parts. Third? Yes.
Thank you very much. I am Rafik Hamdi, working at the Royal Meteorological Institute, Belgium. So, very interesting talk. I am not in your field. I'm not expert on the quantum, but I guess that your method can be also applied to climate simulation, because you put it climate change. So I'm very interested to hear your opinion on this. But my question is, you said that you have 1 minute access to quantum computer. I was wondering why only 1 minute, and which facility did you use for your? Thank you very much.
Yeah, thank you. Now, it is my pleasure to welcome Dr. Mohammed Roba to respond to 3 questions. You are welcome.
Thank you very much. Thank you for the questions. So regarding the IP, for the moment we are a research group within a university, so everything is done within an academic context, let's say. And for now we are not a company and we are not having any kind of investor. We are discussing that. We have the potential to become a company and to create other companies with other people. And this is the first question that we discuss with the different kind of investors, but it depends heavily on where the company is going to be incorporated and how it's going to become incorporated. In Algeria, for example, if you create a startup starting or based on research work that you are doing within the university, then your startup is going to get all the rights on the IP. With other investors from abroad, things are much more complicated, but we are being extremely careful. For now, we are doing this as a research work, and we are having very interesting results, but we are still keeping all the secrets, let's say. We are still keeping all the technology within our group. Even when we are working in collaboration with other groups, we are not given our codes, we are not given our skills, we are just given the results, because this is the skill that we have been developing since 2 years now, and this skill is extremely valuable. So we are not going just to unveil everything. Now we are progressing with many research groups abroad, but we are keeping our IP within our research group. This allows me to make the transition to the second question. So if I well understood, the first aspect of the question was that we are working with people outside Africa instead of working with people inside Africa. I don't think, from my own understanding, that ARISE project aims to do research only within Africa. The ARISE project aims to support African researchers doing research in Africa, in African institution, to raise their level and to explore opportunities they don't have explore other fields that they don't have the opportunity to explore without this grant. Why are we working with people in US, for example? Simply because the technology is there. Each of those quantum computers cost billions of dollars. And we are developing quantum algorithms that we are running on those quantum computers. So we need access to those quantum computers. And we can't have access without collaboration with those people. The paper that I showed, it's thanks to collaboration with those people that we have been able to get access to the state-of-the-art, most developed quantum computer in the world. No one will give you access if you are just a researcher from Africa. So we are trying to smartly collaborate with those people, trying to transfer the technology, acquire the skill from them, acquire the access to those facilities, which are extremely expensive, extremely rare. I will go through the answering the third question on this. But the research is being done in Africa with African researchers, within an African institution, with the Arise African grant. And more than that, as I hope I've been successfully presenting to you, quantum computing, or at least the skill that we are developing, is a transversal skill that have the potential to be applied to many different aspects of science with huge impact on Africa. And we are already discussing with many Arise fellows here to apply our quantum computing skills and our quantum algorithms to their projects on drug discovery. We are already working with the IMNA, the Arise fellow here. We are also discussing on how to apply this to another Arise project on telecommunication, but also on other projects related to chemistry and enzyme production. So we are doing our best for us to ensure that Africa is using this grant for Africa to advance on this field. Sorry for being long, but for the third question, as I said, quantum computers are extremely expensive, extremely state-of-the-art machines. Each of those is costs billions and billions of dollars, and those companies are restricting the access to those machines just because it's state-of-the-art technology. First, but second, it costs extremely. It costs a lot to not only build those machines, but also to maintain those machines. It needs a lot of attention, a lot of skills. So few of those companies are giving public access to researchers to use their machines, to allow them to have use cases on their machines and have this exchange of competences to advance the technology. So this access is extremely limited. On IBM, for example, we have 10 minutes per month per account. And the quantum computer that we used for the warehouse optimization process, it was D-Wave. It's based in Canada, and it's one of the best quantum computers for now. And we got like 1 minute, sometimes we got 10 seconds access per month. And it costs thousands of dollars per minute per user. So again, we can't afford for that if we are going to use this. And for example, for the paper that I have showed with people from NASA, we have been using the IBM Torino, which is the state-of-the-art computer, for 7 hours. I let you imagine how much would have cost such computation if we didn't get the access through our collaborators. So we are doing our best to ensure those access while making sure that we keep our technology within our group. Thank you.
Yeah, thank you, Dr. Mohammed. Ladies and gentlemen, I think we have learned something that we are doing good science in Africa, but in some of the areas, we can be creating scholars who, at the end of the day, will be employed by those who have the enabling environment, because they are experts now in supercomputers, which does not occur in Africa. They are not available in Africa. They can be easily employed in the developed world. This is the challenge to all of us to arise, to think of creating a neighboring research infrastructure in Africa to make sure that we can do such high-tech science in Africa, and we can retain our good brains in Africa. Thank you very much. Now let's move to Dr. Katawura Beltako. Dr. Katawura presented on quantum simulations and energy materials, and I would like to welcome 3 burning questions, if they are there, so that Dr. Katawura can quickly respond. Yes. There is a hand somewhere there.
Can I? Okay, yes, I'm Protus Aritakan from the Institute of Medical Research and Medicinal Plant Studies in Yaoundé, Cameroon. Mm-hmm. I was just wondering, with the electricity problem in most parts of suburban area, I think that is a very important project. But usually when you want to take solar cells, they tell you you need also batteries that would get the charge. And by increasing the capacity of the cells, how does that impact with the batteries that are used? I just want to know, so when you talk with technicians you can get an idea of what it's all about. And thanks for your brilliant presentation. Thank you.
Thank you. Any other burning question? I don't see any hand. Now, Dr. Katawura, please respond.
Okay. Thank you for the question. And actually, the increase of the efficiency of the solar cell is not on the battery, is on the capacity of the cell to convert light to electricity. So when we say 32%, it means your cell is able to convert 32% of the light into electricity. But then this will increase the capacity to produce the electricity. But now, if you want a more huge batteries, this is another topic. This is another research question, like increasing the capacity of the batteries. So this is also other type of materials, lithium ion, and people are exploring new other materials. But this will basically do what? It will reduce the price of production. If you have the price is related to the surface. So if you have a small surface of your panel that is able to produce a very high quantity of electricity to be stored, then in that case we can reduce the cost. It will reduce the cost of production, so solar panels will become more accessible. Even though today they are accessible, we can see that not all people are able to buy it into their home. It's still very expensive for many households. So this is why this research effort is going into that direction. Thank you.
Yeah, thank you very much. Now, next is Dr. Hafiz Yusuf Hafiz. He presented on the development of efficient and robust MXene-based photocatalysts for production of solar fuel, hydrogen, via photocatalytic water splitting. I welcome 3 quick burning questions. Yes, there is one hand.
Thank you. I enjoyed the talk. So my question is, you sort of use light to split your water, right? Have you considered using electricity, like photoelectro water splitting? Thank you.
And your name, please?
I am Gift Mekano from Zimbabwe.
Good.
Thank you.
Okay, thank you. So, you're welcome, sir. Oh, there is a second question. So you are lucky.
Hi, Ahmed Zoba, Brunel University of London, and the chair of SEC for RIs. I am working on hydrogen, and I know I am working very well for green hydrogen, but I saw one of your slides, you colored your hydrogen as blue. So I need to know, is your hydrogen blue? Because if it is blue, there will be carbon emissions coming from your hydrogen. So I need your comment on this. Thank you.
Thank you very much. So, Dr. Hafiz, I would like to take this opportunity to invite you to respond to questions.
Okay, let me start with the first question. As he said that, why can't we consider the photoelectrochemical approach? If you look at our process, we have the photocatalytic water splitting, we have the photoelectrochemical, we have the photobiological. But in my own work, I'm working on the photocatalytic water splitting because it's inexpensive, low cost, and is very simple compared to other approach. But if you look at the one you are mentioning, the photoelectrochemical, you see that you need to have the electricity, you need to have the electrode, you need to have the electrolyte. This one is becoming like a complex one, even though this approach is yielded to have the higher hydrogen production compared to other method, but our research is focusing only on the photocatalytic water splitting approach. With regards to the second question, as the purpose
The blue
saying that
hydrogen.
the blue hydrogen never be a blue, is just like to indicate the appreciation, but that one will be taken into consideration so that the background can be changed. Thank you.
Yeah, thank you very much. Yes, there is an additional question.
Because your hydrogen is uncolored.
Yeah.
It is not blue.
Yeah.
Yeah, because it's still emerging, and we have concerns regarding the environment from your technology.
Yeah.
So you need to prove that you are friendly to the environment.
Yeah, I think this is a homework for you to redo your colors. Yeah, thank you very much. Questions to our last presenter, Dr. Hobby, who presented on earthquakes monitoring and hazard evaluation in Madagascar. 3 questions, yes? Raise one hand.
Good afternoon. My name is Sonia Semed from Cape Verde, and I have 2 questions to Dr. Roby. The first one is, does your model only applies to Madagascar, to mining monitoring, or can adapt it to other earthquakes types? And the second question is, in artificial intelligence, everyone is complaining about data accesses. So could you please try to say us what strategy did you use to get access to data with more than 3 decades? Thank you.
Okay. I don't see any other hand. Oh, okay. Dr. Onyango.
Thank you. I want just for her to clarify on the aspect of technology that she's developed in regard to tremors. When you use diatomite in the mining industry, yeah, they're going to produce a lot of tremor.
Of course.
And her technology that she's coming up with is supposed to help in the aspect of earthquake determination. So how is she able to differentiate the one that is coming out of those diatomite and the real earthquake per se in the aspect of the seismic levels? Thank you.
Thank you very much. Now, I would like to take this opportunity to invite Dr. Hobby to respond to
the questions raised. You're welcome.
Okay, many thanks for the question. Regarding the question from Dr. Sonia, in fact, the idea for the project is to develop the earthquake monitoring for Madagascar first, but the long-term idea is really like to apply the technique for East African Rift, which is among the area that is very active in Africa. And we particularly use Madagascar because many scientists suggest that East African Rift would extend to Madagascar, and that will increase the earthquake activities there. And that was already, and we can already see the sign of that. For instance, the earthquake activity in Mayotte, which is in an island close to Madagascar. It has been quiet for a long time, and since 2018 it is active. So that's the idea. And regarding the validation of our technique, is that your second question, if I understand clearly?
The second question was from the same lady?
Yeah.
Yes.
Data availability. Could you repeat, please? Sorry.
Could you repeat the second question, madam?
What strategy did you use to get access to more than 3 decades of data? Because you train your model with 35 years data, I think. Yeah, so which strategy did you use to access?
Okay, for the machine learning technique that we use, because we have archived data in Madagascar for since even before 1988. But from those, we have really digital data. And the idea is to develop first the model for this part. And the data for the mining were, as I mentioned earlier, of course the data from mining are not sufficient because there are only few data that we obtain. But what we use is that we know that let's say the data from, the event from mining blast, for instance, has this signature. So we somehow use this information to additionally detect what are those events. And then we train, let's say, using first the known data, and then we do the prediction to categorize later what we don't know, because so far we just assume that everything is earthquake, which is not the case. So we need to distinguish those events. Thank you. And regarding the question about the data, how we could distinguish between tremors and let's say mining activity. And in fact, that's the next step, because right now we just use, let's say, events that are being archived. So the next step is to get, let's say, instruments around the mining area, and when we have closer seismic monitoring, we get more information about, let's say, locations. Because here I just consider, let's say, 2 different data, let's say mining event and earthquake. But from that, we have for sure various events, additional events through this next step, which is installing stations really around the Armenian area.
Yeah, I think she's understood that the epicenter of the tremor, when you are talking about surface blasting, underground blasting in mines, and earthquake, you can subtract the two and you can see the difference. And it has already been done in some other places, and Madagascar is also doing great. And they are coming up with how you can subtract tremors due to blasting and tremors due to earthquake, depending on the epicenter of the tremor. Otherwise, let's accord them applause of applause for the good presentation. And I would like to handle the session to the chairperson for the next steps.
Thank you very much for all of you. Thank you. You can applaud them another time. Thank you very much. Now we have just 15 minutes of break, coffee. Yes. There is an information.
Yeah, thank you very much for being attentive and for participating in all the sessions that we've had so far. I really appreciate you for being here and for your participation. Now, we are going to have a little break of 10 to 15 minutes while we prepare for the poster sessions. The poster session will be directly outside. Once you step out of this hall, the other space that is directly opposite this hall will be where the posters are. So in this 15 minutes, please, if you have a poster to present, go out there and put out your poster. We are going to number your posters. So if you put your poster, you see we'll put a small number to your poster. That's to help us identify it. Now, the second part is that while you are waiting for the presenters to put their posters out, there's a table close to the space for the poster presentation. We have there some refreshment for you. You can begin to have the refreshment, but we also expect that during the poster presentation, you can still have your refreshments in your hand while you go through the posters. Now, for the posters, we encourage you to do your best to see every poster. We are interested that you see every poster, ask questions, get to hear about what science is being done by these scientists. The reason is that at the end of the poster session, not today, at the end of the entire conference, we are going to have some awards for the best posters that we see out there. Now, I'm not going to tell you who will be the judge. The judges are sitting amongst us and they know themselves. Okay? They have been appointed, they know their work, they will do their work.
Excuse me, there is another session, don't forget.
Oh, this? Holy cow.
That's why. But after
no,
a break of 15 minutes, they come back, after there is all the program that you
I
have.
think we have.
No.
We've overshot
Not yet,
our
not
time.
yet,
We've
not yet.
overshot our time.
Not yet.
Okay, so I'm so sorry about the. Okay, I've given you too much information already. Let me shut up.
Okay. 15 minutes and we come back. Thank you.
We're not going to do it.
So the rapporteurs are the same. Ms. Ons Masmoudi from Institut Pasteur and Dr. Rowland Opiza from AAS. Okay, so do you want Professor Hamisi Malebo that I invite?
Yes.
Okay. So I invite the first person, which is Dr. Samuel Bunani from University of Burundi. Thank you. Welcome, Dr. Samuel Bunani. And the second person is Dr. Bridget Mutuma from University of Nairobi, Kenya. Welcome, Dr. Bridget Mutuma. Don't stop the applause, don't stop, no? Until she arrives. Yeah. Thank you. And the third person is Dr. Gift Mehlana, Midland State University of Zimbabwe. Don't stop the applause until he arrives. Thank you. Encourage him, yeah. And the fourth and last person is Dr. Ngonye Keroletswe from Botswana Institute for Technology Research and Innovation, Botswana. Yes, applause until she arrives. Until she arrives. Welcome. Welcome, Dr. Ngonye Keroletswe. Welcome.
Yeah, thank you, Chair. Ladies and gentlemen, in the interest of time, I would like to give the floor to Dr. Samuel Bunani from the University of Burundi to present on the development of an electrochemical process for recovery of nutrients from liquid waste resources. Dr. Bunani, the floor is yours now. You're welcome.
Thank you very much, Chair. And as our previous presenter said, I would also take this opportunity to thank all of the organizers of this event and also the funders. And without losing any time, let's go into the project. And I have to promise, though, that you will not get hot head with these quantums that was previously presented. We will be looking on easy stuff rather than these quantum ones. As the chair said, I will be presenting on the development of an electromembrane, an electrochemical process for the recovery of nutrients from liquid waste resources. As I can see everywhere, I can see water. This water will end up somewhere, okay, and becoming waste after being used. Municipalities are treating this water so that they can be released by thinking about an impact in surface water like lakes or seawater, as you know. So we will be trying to see how we can valorize those kind of waste waters by recovering those nutrients. And actually, the main goals for this project was, as I said before, to selectively simultaneously separation the recovery of phosphorus and the nitrogen as the fertilizer. And that at the same time, it is possible to purify the organic carbon, which is also dissolved in these wastewaters. The wastewaters that we have on a target are principally those wastewater treatment plants effluents. We have also this hydrothermal liquid aqueous phase liquids, and also those animal manure slurry, which are being problematic in those days. So within the process, we will recover these nutrients. The nitrogen will be recovered as ammonium nitrogen, while the phosphorus will be recovered as the phosphate, phosphorus, and the organic carbon as dissolved carbon. So within this project, we will be integrated two processes. The first one is the pressure-driven membrane processes. As you can see, it lays from microfiltration to reverse osmosis by passing through by passing through the ultrafiltration process and also nanofiltration process. Within this project, the membrane pressure different process, they can be operated in two modes. The first one is the dead-end mode, which is here now. The next is the closed flow mode. What is the difference between the two ones? The first one, you get your permeate in the same direction as the feed, while on the closed flow ones, you see that the feed is tangential to the direction of where you are getting your permeate. Here, as you can see on the right hand, the last figure, it's the process that I designed, and I asked the company to make it to my wishes. The wastewater that we are talking about is municipal wastewater. You see the tank, which is the feed, and the other part that you see down is the control panel of the process. We will not work alone. It will be integrated with the electrical driven process. This one has been made to using a property of a membrane which is bipolar membrane. Before they were talking about water splitting. This membrane has the property of to split water itself under the current. For this time, it will produce OH on one side and on the other side H+. As you can see on the here, this one will be producing, for example, ammonium will not be touched, but the ammonia, as long as it is neutral form, will be transformed in ammonium with the acid which will be produced by membrane. But in this way, you will be increasing the mole of the ammonium which can be transferred under the current within this process. The process, this is the first picture, is the front of the process. This is the back when you can put your tank, your water after getting the filtration. The wastewater that I was talking about is this one. It's a rouge, sorry. It's a rouge surface water. No, sorry. And then in this way, you can see that after this one, you can go, we went to the sampling. This is my team. We went to the sampling on this wastewater treatment plant, and we collected this water to bring to the lab or to where the process is. After those ones, we were able to apply the pressure-driven membrane that I told you about by using ultrafiltration. And when we look on the result that we get, we have seen that within this water, we can decrease the organic carbon from around, for example, 95% when you apply a pressure of 5 bar. But as you can see, there is a difference in pressure. When you increase in the pressure, you really release more carbon. But the one that will release, it's in the concentrate side. But for the permeate, we will get, you see that on this one? This water is the permeate, while this one is the concentrate. In this one, we have organic carbon, while in that one, we have the phosphorus and also the nitrate. After that, we take those within this pressure-driven membrane, we were able to generate and permeate around 35 milligram per liter of phosphorus, while the nitrogen, depending on the feed, of course, it was around 65 milligram per liter. For those ones, we take them and we feed in the electromembrane process, so that we can then at this time to separate them. Because the issue is that if you have both of water and you have nitrogen, phosphorus, and organic carbon, people are now using, if we want, wastewater as they are. But the issue is that it's unbalanced. This process will be implemented in order to separate all of those components so that later on they can be used separately. If you wish to use, for example, this kind of phosphorus only, you can use the effluent phosphorus. And if you want to use, for example, nitrogen, you can use nitrogen only. On the other hand, you will be safe and you will be using as you wish. If you want to combine them, there is a blending ratio that we have to find in between so that you can produce a green fertilizer depending on the requirements. And in this time, as you know, those biological treated wastewater entering the surface water, they are harming our surface water where we get the food. We were enjoying fish here, but those fish will not alive. We will release those kind of biotreated wastewater in the lake, for example, because they will be producing this algae bloom, which will cover the surface of the water, and then the fish will not get this enough dissolve the oxygen and the light so that they can survive. This is one point that will be within this project impact of this project on the environment. And on the other side, we will be getting those green fertilizer that can be used in agriculture depending on the need of the soil and also of the plant. Because it's not all of the plant that need this and that nutrient. It depends on what you want to use. So briefly, if I look to the contribution of this project to the AU and the EU high-level policy dialogue on the science and the technology and innovation, this project within the public health protection will be ensured by green technology for liquid waste stream management. And at the same time, this will contribute to the achievement of Goal 6 of SDGs, which is clean water and sanitation. But the innovative aspect of this scientific project will avoid injection of other chemicals for recovery of these nutrients compared to the current technology, because normally in the current technology, we are putting acid and base to convert those nutrients in the way that they can be recovered. But in this process, it's the process itself to produce the acid and the base to convert the nutrients in the recoverable way. And the recovered balanced green fertilizer then will improve the crop production and the plant growth in agriculture, which will contribute, of course, to some extent to the achievement of Goal 2, which is zero hunger of the SDGs. Briefly, it's one even. By recovering those nutrients, reducing chemical inputs, the wastewater discharge in surface water, the project will be better food and the societal economical improvement by the utilization of this green fertilizer in agriculture and the production of the environment by the innovative liquid waste management. Thank you very much. This is the end of my presentation.
Thank you very much. That's it.
Yeah, ladies and gentlemen, I would like to invite the second presenter, Dr. Bridget Mtuma from the University of Nairobi, Kenya. She will be presenting from plastic waste to low-cost carbon in nanoreactors for use in monitoring environmental pollutants and nanoplastics. Dr. Mutuma, the floor is yours now. You're welcome.
Good afternoon, ladies and gentlemen. It's a pleasure to be here. I hope that you've enjoyed your coffee and that you're excited about this session. So as Professor Hamisi has mentioned, my name is Bridget. I am an ARISE, a fellow, an affiliate of the African Academy of Science, as well as a fellow of the African Science Leadership Program. And my ARISE project is based on the conversion of plastic waste into nanomaterials for monitoring of pollutants and nanoplastics. Now, since 2019, there has been a prevalence in plastic waste that is being generated. And currently, we have over 400 million tons of plastic waste. And out of these plastic waste, only 9% is recycled. 12% is incinerated, and the remaining percent is put in landfills. And it is projected that by 2050, we'll have approximately 12 billion tons of plastic waste being generated. And that means that you're likely to have more plastics in the ocean than the fish, which is very worrying. However, it is important to note that different countries have put on different policies to be able to curb plastic pollution. This includes the ban of single-use plastic, as well as the adoption of the circular economy, so whereby instead of using and disposing, we're talking about make, use, and recycle. However, during the recycling process, there's always the tendency to cause wear and tear, leading to fragmentation of plastics into microplastics. And microplastic pollution is a big issue currently. This is because when you're dealing with microplastics, we're having small particles of plastics that are between 1 micrometer and 5 millimeters. This can further fragment either through mechanical forces or sunlight to form nanoplastics, which are between 1 and 100 nanometers. And these microplastics can find their way in water streams or even airborne, for example, in textile industries. And they've been found in foods and beverages, which means it's a big concern, especially when we're talking about food security in Africa. Now we not only have to deal with lack of food, but now we also have foods that are contaminated. The microplastics have also been discovered, that was in 2020 in the human placenta, meaning that some babies may be born having the presence of microplastics in their body. And then also in 2022, it was discovered in the human blood and breast milk. So that means you're actually dealing with a bigger menace than just the plastic waste that we see. So my project focuses on addressing the issues of clean water and sanitation, good health and well-being, affordable and clean energy, as well as sustainable cities and communities. I do this by answering the question on how we might mitigate plastic and microplastic pollution by applying, for example, nanotechnology. So the main objectives of my work in Kenya are, first of all, to determine the composition of microplastic waste in several cities in Kenya, to be able to convert this plastic waste to carbon nanomaterials, and also be able to fabricate metal oxide carbon nanoreactors that can then monitor not only environmental pollutants, but nanoplastics. So it's a whole cycle. It's also a circular economy in terms of how to manage plastic waste. When I got the ARISE grant, I had just moved to the University of Nairobi, and I was given a lab space. That's all I had. So through the research, the ARISE funding, I was able to set up a lab. So in terms of research infrastructure and development, purchasing basic equipment, because it was an empty room, virtually everything from scratch, from consumables to all the basic equipments, the key synthesis equipment, for example, a deposition reactor, analysis equipment for plastics like a thermogravimetric analyzer, which is actually a state-of-art equipment, and the first one of its kind in Kenya. So opening a platform for researchers in the faculty as well as in other African countries. And as you can see there, those are just images of the current status of the lab. Also, in regard to that, through the ARISE project, I was able to recruit students to work with and to train, mentor, and supervise in this area of nanotechnology, looking at how to mitigate plastic pollution. So I've been able to, currently I'm working with 8 students. 2 PhDs and 2 masters are fully sponsored by the ARISE project. And then the 2 undergraduates are interns, and the 2 other PhDs are partially funded. So they have got other sources that they use for their funding. Also, when I started this project, I only knew 2 people of all these collaborators here, and I didn't know how to work with them because I want to send samples and I have got no money. So the ARISE grant allowed me to actually now start fruitful discussions on how to collaborate with them. It also created a platform for me to be able to interact with other researchers in Kenya and in Africa, such as Senegal, Zimbabwe, and also in the UK, Netherlands, and USA, because through my profile and through even getting this grant, I was able to be invited to meetings like conferences, Africa, AU, EU, Innovation Agenda, US Africa Program, Capacities Program by Brazil. And through these, I was able to grow collaboration so that we can be able to access facilities such as high-resolution imaging techniques that are not available in the country, therefore being able to leverage what we have in our networks in ensuring that we are able to carry out this research. Yeah, okay, so to do this, I do 2 main things. I'll just give an illustration of what I've done so far, because the setting up took quite some time. So we've been able to repurpose plastic waste into porous carbons. That is, we did an investigation of plastic waste in Nairobi River, some sections of it, and we're able to see that we have polyethylene terephthalate wastes being the majority pollutant. Then we converted these to porous carbons, and then we used it to absorb environmental pollutants, such as textile dyes and antibiotics. And we actually managed to remove quite a large percentage, over 99%, of these pollutants in the water. Now, because microplastics also are not only in aqueous media, but they're also in air, we looked into materials that can be able to detect them in air. So we're looking at catalytic semiconducting oxides that can be able to detect organic pollutants. And we did this by making hollow nanostructures where we were able to detect, in this case, we looked at carbon monoxide as our preliminary study case, and we're able to detect it at room temperature. So, of course, this project is in initial stages, having known that the setup takes quite some time, but everything is all set with the students and with the facilities, so we are moving forward towards implementing the full goals and meeting all the objectives of this project. But one thing I want to emphasize is that there is still need for us as researchers to be able to resource mobilize, to be able to get some more equipment. For example, microplastic analysis. There's very little that is within the continent, and among the few who are doing it, therefore we need to be able to get more resources for that. So how is my project relevant? It helps in building the capacity of the university, both infrastructure and human, while addressing plastic, air, and water pollution. And also it's relevant to the AU-EU dialogue on STI, which is on building the capacities for science, as well as looking at innovation and technology. Of course, using these waste materials can help in generation of sustainable cities and communities because you're able to convert this plastic waste into a useful product. The findings of this work can fill a knowledge gap. Microplastics have got a very big knowledge gap on the life cycle analysis towards how to mitigate them with a low-cost process. It can also help in the development of methods of standardization, especially for nanomaterials, as well as looking into plastic waste management and nanotechnology development policies, not only in Kenya, but in sub-Saharan Africa. And lastly, of course, it can help in policy engagements on the management of wastes containing nanomaterials. So without any further ado, I'd like to acknowledge the African Union, the European Union, the African Academy of Science for this opportunity, at the University of Nairobi, my collaborators, partners, and my students, and of course, you for listening. Thank you.
Thank you very much. Yeah, thank you, Dr. Mutuma, for the good presentation. Now it is time for Dr. Gifty Merana from Midlands State University of Zimbabwe. He will be presenting on water-stable porous metal organic frameworks as host materials for biological catalysts in carbon dioxide conversion to methanol. Dr. Gifty, the floor is yours now. You're welcome.
Good afternoon, everyone. Good afternoon, everyone. Oh, good evening. I'm reminded that it's evening, but still afternoon. Thank you very much for that. So, my name is Professor Gifty Mekana from the Midlands State University. I am only about 4 months old. I was promoted in January, thanks to the African Academy of Sciences and the European Union and the African Union for funding us. When I started this program, I was Dr. Gifty Mekana. Now I am Professor Gifty Mekana. And again, thanks to our funders. So for me to get to this point, I had to travel. So this is the way we see the world in Zimbabwe. We are up there. So I had to go down to Dubai and then connect to Tunis. So it was a very long journey. So you must congratulate me for making it to this point. And what you see here is the Midlands State University. That's our new administration building. So let me dive straight into my research. So what I'm going to do today, I'm not going to tantalize you with my chemistry, but of course I'm going to take you through the journey that I've walked with the African Academy of Sciences. In developing my career, for your own information, I was part of the first cohort of the flare. And then after the flare, when the UK government decided not to renew, I also put my proposal for the ARISE. And I was successful. So thank you very much again, the European Union and the African Academy of Sciences for coming up with this, because otherwise I could be somewhere not in Africa by now, but I'm still in Africa. Thank you so much for that. So as you all know, the issue of carbon dioxide, I don't think I have to emphasize that. We all know we have emissions from industries with the aim of getting energy when we burn fossil fuels. And these sort of contribute about 30% of the global emissions. The world is now moving towards the net zero effect. In other words, we want to reduce the emissions. I know different countries have set different time frames for reaching what we call the net zero effect. In other words, we are reducing the emissions. So what can we do to this carbon dioxide? I think that is my research. The whole idea is to capture carbon dioxide from the point of source, and then not just capturing only, but we can also utilize this carbon dioxide to give other energy materials that we need for our everyday lives, especially for the 21st century. So we do have different utilization strategies for carbon dioxide, and I want you to look at I think there has been a lot of storing carbon dioxide, that's geological, right, underground, as you can see there. But you can also transform your carbon dioxide. You can either use chemical means, or you can use biological means to convert your carbon dioxide to fuels that you need. So in a way, when you capture carbon dioxide, it means you are reducing the emissions, you are fighting climate change, you are fighting global warming. When you then transform it to useful chemicals, such as methanol, which I believe is a green solvent, is very important as we move towards a green economy. You see, so you are killing two birds with one stone, capturing and of course converting. And we have demonstrated through those publications that it's possible to sort of capture carbon dioxide and then convert it to useful chemicals. And in those 3 publications that you see, we published them last year. We managed to convert the carbon dioxide, we managed to capture and of course convert the carbon dioxide to formate. Formate is the blue hydrogen. I know there has been some discussions about blue hydrogens, but blue hydrogen is a starting raw material for many industrial processes. Very, very important. So I say we must prepare for a net zero world where we cannot allow anthropogenic carbon dioxide to escape into the atmosphere. And then this sort of brings me to my project aims, which is basically to develop novel porous materials for housing biological catalysts for capture and conversion, of course, to methanol. Not only methanol, you can tweak the reactions, which I'm not going to talk about, to produce various chemicals that you need from just CO2. Remember, carbon dioxide is the building block for many organic compounds. If you think of the process of photosynthesis, we are starting with carbon dioxide to get the food that we have been enjoying today during lunch hour. That's where you are starting from. And of course, the other aim is to train the next generation of scientists or African scientists with specific profiles in the energy sector. As you can see on that diagram there, that's one of the materials that we make. Let me see if I can use this pointer. Okay. Unfortunately, okay, because of the light, you won't see. But that material, which is on my right, those are what we call porous materials. And that's what we engineer in the lab. That's what we call crystal engineering. We make materials by design for specific applications. This kind of research allows students to think outside the box. The only way you can eradicate poverty is to provide quality education. And when you allow students to think outside the box, it means in a way you are solving poverty. It means they'll be able to proffer solutions to the challenges that we are facing in the 21st century. So we aim to design materials which can capture carbon dioxide, right, and convert to methanol. But in those channels that you see, it's porous, they are porous. There's space where we put the biological catalyst, which then does this conversion to methanol through a cascade of reactions, which I don't want to talk about because I don't think that's the right platform. But of course, if you then engage me, I can tell you more about that. So the key milestones from what we have been doing in the last 2 years, we have managed to recruit 2 MSc and 2 PhD students. We have prepared a wide range of materials which are able to capture carbon dioxide and of course, with enough space to house our catalysts. Remember, our catalysts are the enzymes. There is a specific reason why we chose the enzymes. And of course, capacity building in material preparation and characterization, regional and international collaborations. We've managed to have that, and I'll talk more as I go ahead with this presentation. So, what is the impact of this project? I don't want to lie to you, but there is increased knowledge based on the African continent. Ladies and gentlemen, I can tell you that we have been approached by researchers from Europe to say, we've been working in all these continents, except for Africa. We do not have partners where we can start to map industries which are producing carbon dioxide so that we design the right sorbent materials, or we work with the right sorbent materials. Their argument is that you cannot apply all the sorbent material for CO2 in all the industries. It's not applicable, so you need to find the right. So we are getting into that collaboration where we sort of look at the African continent, what are the sources of CO2, which sort of materials can we use, and this we are going to do through computational calculations. Thank you very much. I'm about to finish. So that's the sort of impact. And I can also tell you that we do now have what we call the Net Zero Coalition Zimbabwe, which is with an aim to accelerate reduction of emissions. And I'm part of that group, and I'll provide guidance on how we can do, especially in the chemical sector and other areas, because we have a lot of sources of carbon dioxide, not only from the industry. Like I said, the industry, they just contribute about 30%. We also had a meeting of minds in January just to see how far we have gone. And we had a visitor from Sweden that we were working on with or collaborating with on this project. And then we mapped a way forward for the next 3 years. And some of the things that we need is computational modeling, understanding or evaluating enzymatic specific reactions in the metal-organic frameworks, and of course, evaluating the performance of the sorbets that we make. Right. Like I said, I have a lab. When I was awarded the FLAG grant in 2019, I was allocated the lab by the Midland State University. I managed to buy equipment in that lab. But of course, the equipment, you know, in material currency, you need a lot of equipment. And thanks to the RIS grant again, I managed to buy this high-end piece of equipment that you see there, where I'm laminated there. It's a beast, I can tell you that. It costed us around 1.8 million rands, and it will allow us to understand our materials better. Which materials have a high affinity for carbon dioxide? It can tell us. Which materials has high affinity for hydrogen storage? Remember, we are also moving towards the hydrogen storage economy, right? Where we use hydrogen as a fuel. This material can tell you. We have issues of clean water, and in some of the projects that we do, we capture water from the atmosphere using the materials that we make. This equipment can also tell you if your material is performing well with regards to water capture. So once again, I have to thank, and I want to stop to thank. I'm so grateful, I'm so excited. I wish I was at home to run this equipment, but my students are doing it. Thank you very much, African Academy of Sciences. Last year, we also had another small grant which gave us around $50,000 US, and we managed to buy the UVVs that you see there. Yes, and it's used to characterize enzyme concentration and other things. And then that's my research group. It's very energetic. I have very brilliant students who work so hard and smart to get what we need to achieve the objectives of the ARISE program. And of course, I also want to thank all the people that I work with around the globe. We don't do our research in silos. We work with a number of partners to have access to the state-of-art equipment around the globe. At this particular point in time, I want to thank the organizers of this event, the African Academy of Sciences, the European Union, and the African Union for making my research career a possibility that I was always dreaming about. Thank you very much.
Congratulations, Gift, for the good presentation. Ladies and gentlemen, it is my pleasure to invite the last speaker for this evening. That is Dr. Ngonye Keloleswe from Botswana Institute for Technology. She will be presenting on sustainable water filtration using cellulose-based membranes derived from local biomass. Dr. Ngonye, the floor is yours.
Good evening, everyone. Okay, thank you very much for having me here. It's an honor to be sharing this space with the top in the industry, the top in the research field. I'm very much honored. And I just want to thank the AAS for reviewing just my proposal and believing that I can be part of the young minds that can make the change in the world. I'm grateful for that. Thank you very much. So I'll be telling you the story of my research. I call it a story because this is the passion that I have. I'm looking at making cellulose-based membranes for water filtration, and that cellulose, we are taking it from local biomass. So local biomass, we are talking about the plants, we are talking about the natural resources that are surrounding us. Currently, I'm a senior researcher at the Nanomaterials Division at Botswana Institute for Technology Research and Innovation, BITRI in short. Just like Gift, I'm also honored because ARISE made sure that I get promoted last year, January 2023, from the position of researcher to the senior researcher position. So, which is leading from the front rather than leading from the behind, what I was doing in 2022. So it's an honor, thank you very much. So basically, I'm looking into water filtration because of the challenges that we all know, that access to fresh water is a challenge world over. Botswana is not an exception. Botswana is a landlocked country. We have no access to the sea. So because of that, we have water scarcity as one of our main challenges. So we have some rivers, some of them they dry out part of the year. So it's a struggle, but we have a resource, which is treated wastewater, that up to right now, not much of it has been taken back into the system. So because of those challenges, we set out to fabricate or to make cellulose-based membrane. The reason why we chose cellulose is because it is abundant. You can find it in plants, you can find it in marine animals, you can find it in animal waste. So it's a lot, it's everywhere. So because of that, we thought it could be a resource that we tap into and use it as a base material. So currently the membranes that are in use, they are made of synthetic polymers. So because of the good properties of cellulose, it is biodegradable, it is non-toxic, it is compatible with many biological systems, we thought it could be an alternative to the synthetic polymers that we are currently using in water filtration. So the aim of my research is to address issues of water contamination using cellulose derived from local biomass, and to train the new generation of scientists who drive the knowledge economy. We know that Africans, we are mainly dependent on our resources. So we want to move to a system whereby we can use the knowledge that we have to drive our economies to improve human life. So basically that's the aim of my research. And the objectives, the first one is to develop membranes, cellulose membranes to target different contaminants. We have issues of salinity, we have issues of toxic metal ions, we have issues of anions. And then we want to come up with methods, protocols that other researchers can follow to be able to use resources in their environment as well to purify water for themselves. And the most important one is that we want to train the next generation of scientists. So on this slide here, I have an overview of the project that we're doing. Currently, we have enrolled 6 students, 2 PhD students, and 4 master students. And maybe I should mention that I come from a research institute. So because it's a research institute, for our students to get qualification, they have to be affiliated to the university. Therefore, the first year of the grant, I spent reaching out to other researchers in the university, establishing agreements, finding ways of working together with universities so that we can be able to carry out the ARISE project. So what I have here, I have 6 students. So I think I'll use the numbers 1, 2, and up to 6 that are showing on the screen there. So the first student, number 1, is a PhD student. I've come with her here. I think you interact with her during the poster session. She'll be telling her a story. And her story is on taking elephant dung, converting it to cellulose, and using the cellulose to make filtration membranes. So I'll not go into the details because the student is here so that I don't steal her spotlight. And then the second student It's somebody who comes in an area where we have invasive plant species. And that species is called honey mesquite. It's a Prosopis glandulosa species. So this plant was brought to Botswana to come and counteract the desertification. Because as you may be aware, Botswana has about 3/4 of Botswana is a Kalahari desert. So because of that, the plant was brought to Botswana. However, not much research was done into the plant. Now it has colonized many areas in Botswana. What you can see there, here, oh, I don't know whether I can be able to see my pointer. So this here, all this bush here is that species. It's between the border of South Africa and Botswana. So this is where we went to collect the species, and this student here is the one who is interested in that work because this is, the species is a problem in the place where it's coming from. So what he's doing, he's extracting cellulose from it and then using the cellulose to purify quaternary ammonium ions from water. So these quaternary ammonium ions are coming from the detergents that we're using, the sanitizers and everything. They end up in the wastewater treatment plant. So from that species, we are hoping that we'll be able to purify quaternary ammonium ions. And then student number 3 is a student who is working on sisal plant. So sisal plant also, just like honey mesquite, comes from Mexico, and it found its way in many African countries. Kenya, I know in East Africa they have a lot of it. And in most cases it's used for its strong fibers. So in Botswana, it's only used as an ornamental plant. You find it around homesteads. And the moment you grow it there, it starts blooming and killing other indigenous species in its surroundings. So because of that, we looked into those fibers and we realized that there is high cellulose amount, roughly close to 50%, if it's not 100% pure. So because of that, we thought this could be a good resource that we can use as a base material for water filtration. And then we have student number 3, 4, 5, and 6. They also get their cellulose from the sisal plant for water filtration. Student number 4 is targeting toxic metal ions. Student number 5 is preparing electrodes, carbon electrodes from the sisal plant for capacitive deionization of water. So this process here is trying to remove the salt ions from the water so that you can regenerate the water for human consumption. And then student number 6 will be taking that, thank you for enlarging that. Student number 6 will be taking cellulose from the sisal plant and she'll be preparing an electrospan cellulose membrane. So one thing I must say about BITRI is that we have a facility called Center for Material Science, where we have various equipment for material characterization. And one of those equipment is electrospinning units. We have at least 2 pilot plant and then the small lab equipment. So because of that, we thought we could tap into electrospinning and make membranes for water filtration. So where we are is that student number 1 has managed to functionalize cellulose that removes roughly about 80% of lead from spiked water. And then student number student number 2 has just started. We just obtained the permit for harvesting mesquite in February because it's a protected species. It spreads quickly, so we have to go all through the process of acquiring a research permit. So he has just started and currently has managed to extract cellulose from there. And then other students are just starting. Student number 5 and 6, they're at the initial steps of their research, so there's not much that I can say on those 2. So basically what we see here is potential of cellulose in water filtration. So the first thing that we are proposing is that because this resource is abundant, it is affordable, if we use it as a base material for water filtration, we are hoping that the resulting membranes will also be affordable to the communities. Because one of the reasons why people struggle to get fresh water is inability to be able to purify water for themselves. So if you provide membranes or water filters that are affordable, communities will be able to purify water for themselves, and their access to clean water will be increased, contributing to SDG 6, safe water and sanitation for all. So, thank you very much for reminding me. Yes. So another thing that we are looking into is trying to convert the challenges associated with invasive plant species, that they overpower indigenous plant species. They also, especially mesquite, it has long tap roots. It draws a lot of underground water, resulting in boreholes drying in those localities. So we are thinking that if this species can be uprooted and be used for a good cause, then we'll preserve indigenous species. We'll also preserve the most important resource, which is underground water, because in Botswana, like I said, is a landlocked country. Most of our water comes from the boreholes. So we also have a high population of elephant, one of those countries with the highest population of elephant. I think it's roughly about more than 130,000 elephant in Botswana. So because we have this large head of elephant, they consume a lot of biomass, and in the process they produce large quantities of dung. And from one elephant, it is estimated that it can produce roughly about 150 kg of dung a day. And from that dung, we have discovered that most of it is undigested biomass, which contains lignocellulose material, which is a good starting material for us to get cellulose. And we've discovered that from the just extraction, we get roughly 50% of the washed dung as the cellulose. So which is a good resource for us. And we're thinking all this put together, we can be able to contribute to manufacturing. Botswana, mostly we depend on imports. So we are thinking if we can get membranes that are of good quality and they can enable people to purify water for themselves, we can be able to commercialize the material, because B3 is about commercialization. It's about taking research from the lab to the people. So basically, as we continue, we'll see our slogan is from you to us for you. So we are making solutions that are trying to solve people's problems. You come to us with your problem, we take that problem, we make a technology that can solve it and take it back to you. So basically, that's what we're trying to hope to achieve, to contribute to manufacturing, such that we have maybe a startup that can be able to produce cellulose from the methods that we would have developed. We have a startup that will be able to make water filters, which is contribution to manufacturing. And in the process, we'll be empowering these communities where now their livestock is not able to graze as they used to be into the velds. So we give them something to hold on to, that these invasive plant species, the mesquite, can be taken, sold to whoever would have the rights, so that the communities can be able to generate water for themselves. And in the process, if the membranes are affordable, we are looking into a situation whereby people will be purifying even more water than they need, which they can be able to sell to others, thereby generating water for themselves. So basically, this is the team of the brilliant minds that I'm working with. They are affiliated to 4 universities in Southern Africa. 1 is registered with UNISA, 2 MYC students with BUST, 1 is registered with Tshwane University of Technology, 2 are registered with University of Botswana. So I would like to thank my employer for giving me an opportunity to go and try to implement the ambitions that I have, trying to contribute to the welfare of our people. I want to thank the 4 universities that I'm working with, who gave us an opportunity to be able to train the new generation of researchers, and also the sponsors, which are European Union, African Union Commission, European Commission, and African Academy of Sciences. Thank you very much for listening and for having me here.
Congratulations to all presenters for good presentation. It is obvious that ARISE selected brilliant African scholars, and they are doing great. Now it is time for questions and answers. In the interest of time, I will take, in the first round, one question per presenter, and after they have responded, then as we are running short of time because we need also to view posters, then the rest with the questions, we can continue discussing with them during the poster session and also during the free time. Now, let me start with Dr. Bunani. He presented on the development of an electrochemical process for recovery of nutrients from liquid waste resources. Questions to Dr. Bunani? Yes. There's a hand.
Thank you. Thank you for the presentation, Sam, Dr. Sam. My question is about the functionality of your electrochemical membrane. You mentioned that it's kind of splits water into proton and hydroxide ions, and that's where you are able to trap ammonia or to trap phosphorus, etc., which sounds good, but I'm just wondering what could be the fate of other cationic pollutants, such as heavy metals. What could happen? Would they be also recovered in the process? Would they be trapped in the membrane? And then second part of the question would be, if they are trapped in the membrane due to electrostatic interactions, then what happens? How do you renew the filtering capability of the membrane? Thank you.
Okay, thank you. Brief response.
So, thank you very much for the question. Actually, the bipolar membrane, I forget to mention that it has an interface that when it is within water, okay, in interface, water goes in, and the electricity split water that will be producing OH minus and H plus, as I said. So your concern is about the heavy metals or other components that should be in your effluent or your feed. Actually, I recently submit a paper, and it has been accepted on the separation of heavy metals and the organic matters from surface water. You can write in MDP molecules journal, Bunan somewhere you will see. So the heavy metals are adsorbed on a membrane, an ion cation exchange membrane, without any bad impact on a membrane itself, because by producing those acid and base, there is a washout when you use your water to clean the membrane. The only element that was very stuck on a membrane, it was a chromium, but itself, it was stuck in a membrane because of the organic matter that was there. It was normally humic acid, because I was looking at the interaction of heavy metals and the humic acids that can be found in surface water. So in this point, you may be sure that cations can be also moving, but heavy metals will be stuck in the membrane, and by simple washing with water, they can be removed on the membrane, and you will see also the scan images on that paper so that you can understand that the effluent will not contain heavy metals, but they will be stuck on the membrane, and by washing, you will release your heavy metals. That was the first concern, even when we were thinking to recover those kind of nutrients from the wastewaters, because these wastewaters may be the collection of municipal and the industrial ones. So this is the answer that I can give you now. Thank you.
Thank you. Dr. Bunani for the good response to the question. Next is questions to Dr. Bridget Mutuma, who presented on from plastic waste to low-cost carbon nanoreactors for use in monitoring environmental pollutants and nanoplastics. Audience, any question? Yes, I could see one hand.
Yes, thank you very much, Dr. Brigitte, for the wonderful presentation. My name is Dr. Norbert Dukuze. My question goes to, as you presented the presentation about the microplastic, as far as human health is concerned, I just want you to take us, maybe if you try to analyze the size, the composition, or the type of microplastic as human, they are the final consumer of this microplastic in food chain. Thank you very much.
Yeah, Dr. Mutuma.
Thank you very much for the question. Indeed, it's a very important question. So for the microplastic composition, I look into water samples, like the rivers, the surface waters in Nairobi, and I'm able to extract the microplastics, determine their composition, as well as their quantity. So I've not shared that data yet because it's still not yet published. But we do that for us to be able to determine actually what type of plastic or polymer are we dealing with in this microplastic. So we do that kind of analysis before we can proceed to the conversion to the other nanomaterials. In terms of looking into the human health, I do not deal with biological samples. Thank you.
Thank you, Dr. Mutuma. Now the turn is to Dr. Gifty Methilana from Zimbabwe. He presented on water-stable porous metal organic frameworks as host materials for biological catalysts in carbon dioxide conversion to methanol. Yes, there is a question here.
Thank you for the floor again. Dr. Gift Milana, thank you, Professor, sorry. Great presentation and interesting work, because usually people are only looking for ways to trap carbon dioxide, and sometimes such systems are oversaturated, and then the system just loses the capability of doing what we want it to do. So trying to transform the carbon dioxide into something else, it's very important. But the only concern I have is, given the fragility of biologics like enzymes, how might we ensure long-term stability of such filtration systems? That's number one, because it should have some lifespan, so we need to make sure. How do we determine that? How do we make sure that it lasts longer? And thirdly, we are converting carbon dioxide into methanol. I heard methanol is green gas, but I know it's a very toxic organic solvent. So it may easily denature things like proteins and enzymes. How do we ensure that the enzymes still survive even in the presence of methanol? Thank you.
Thank you very much. That's a very important question that you have just put across. Of course, I didn't highlight that during my talk because of the time. The reason why we are using enzymes is because they are highly specific, and of course, they can do those reactions with minimum energy. These are natural systems that have perfected over the years on how to convert carbon dioxide to methanol. But one of the biggest challenges why these enzymes have not been used for industrial application, like he said, is because they are sort of destroyed under harsh conditions. And one way to get around that is to have an environment that we create. So the environment that we're creating, these are what we call porous metal organic frameworks. Metal organic frameworks. So ideally, you can put your enzymes inside the metal organic frameworks, right? And protect it from harsh conditions. That is the whole essence of using metal organic frameworks and enzymes. So you protect the enzyme from harsh conditions when you use metal organic frameworks. So you can use them for several cycles, but of course there are issues to do with leaching. The enzymes might just move out, but we do have a lot of techniques that we can use to just overcome issues to do with the leaking of the enzymes. But so far, from what we have done, we have demonstrated successfully that when you put these enzymes, they can go for close to 10 cycles whilst they maintain their activity. So that's the reason why we are using metal organic frameworks. I will tell you that metal organic frameworks, we call them skyscrapers because we can do everything that we need. We can modify them to suit the chemistry that we want to do. So our enzymes are always protected by metal organic frameworks, and this is why we are bringing them. There has been some research when people are trying to use other sorbent materials, but it's not working because you can't modify other sorbent materials to have the right pore size where you sort of fit the biological molecules. You know, enzymes are bulky biological molecules. So we engineer porosity, we engineer defects in these materials to ensure that they fit, and once they fit, then we avoid all issues to do with denaturing and destroying the enzymes. Thank you very much.
Thank you, Professor Netlana, for an interesting explanation. I think research needs to be continued in that direction. Still quite a number of questions to be answered. Thank you very much. And questions to our last presenter, Dr. Ngonye Keloreswe. She presented on sustainable water filtration using cellulose-based membranes derived from local biomass. Yes, I could see quite a, yes.
Thank you very much. My name is Boniface. I'm from the African Academy of Sciences. And thank you very much for your presentation. Let me say, first of all, that I'm a sociologist, a social scientist. Now, when I listened to your presentation, it made me smile. I was smiling in irony because we have something we say in sociology that you can never solve a problem. You solve one problem, you create another problem, and you keep solving problems. So your country, because of the encroachment of the desert, decided to import sisal and mesquite plants to fight the desertification. And then, after a short while, you are now seeing that that plant has spread so much so that you are now interested in, I don't want to use the word killing it, you want to deforest, or you want to remove some of it because it's taken so much, it's killing the indigenous plants, and the roots are so deep. I think, and I'm maybe wrong, but I think that's the very reason why the plants were imported into Botswana because of the desert. And so have you considered the impact, long time, of your proposition and your suggestion to figure out how to use that plant? In fact, remove that plant so that indigenous plants can survive. Remember that the indigenous plants were not doing very well, which is the reason why the sisal and mesquite were imported into Botswana. How do you address this?
Thank you very much. I think this is a difficult question for Dr. Ngonye because, anyway, let me not answer on your behalf.
Thank you very much. Actually, I was tempted to go and sit down because of answered for me. Yeah, thank you very much. Yes, the mesquite was imported into Botswana to solve the issue of desertification, not the sisal. Sisal, we haven't yet established the reason why it was brought into Botswana. Yes. So it was, when it was brought in Botswana, it was planted into the Kalahari region where we have the desert. But this plant produces some seeds in pods. So animals eat this pod, and wherever they drop the pod, the plant grows. So that's how it ended up leaving the desert region to even other regions where there's no desert. And another thing, because of time, I was just hurrying through, the government has made strides into trying to exterminate the plant. There is a project that in 2019, they injected 100 million pula into extermination of the plant. And where we are, they're trying to find other ways because they realize that solution is not a solution as such. So they're trying to find other ways. And then we came up with this idea that, okay, since you are in the process of exterminating the plant, how about we take this plant and get this useful resource, this useful polymer that we can use to solve another problem. So where we are, it's a way of trying to find how we could manage the problem. We are not like, we want to try to exterminate it completely. We want to make it as a resource that will be continuously feeding into a process that will be solving other people's, another problem of water contamination. At the same time, we have this resource because it's continuously spreading. Even if you try in the on the South African side, what they do is they cut or they apply so something, some dust, some chemical dust, you apply it on the trunk of the plant. So you leave it for some time and then it kills the plant. So this is a temporary solution. After some times, animals bring it back. So it's a cycle, it's a continuous cycle that is not ending. So we are trying to coming up with a positive way of controlling this so that we can benefit from it. On the issue of I think I forgot the second part on the indigenous plant. Can you please remind me the second part of the question?
My whole question was about planning for the future. So you are trying to solve this problem now, and once you depopulate this mesquite plant, then you open the land, you open the country for desert encroachment again. And then are you going to be running around in circles once the indigenous plants cannot, in fact, they are not doing well in that system. So killing the mesquite to allow the indigenous plant to survive is not a solution because they were not doing well in the first instance. So what is your plan long term to deal with the plants as you want to deal with it, but also to avoid desert encroachments?
Okay, thank you very much. Well, the indigenous plants were doing well in other areas where now we have mesquite killing them. So we are trying to preserve the areas where initially there were no mesquite and indigenous plants were doing well. So we are trying to preserve that, but at the same time, where mesquite now is a problem, in the desert, even drying up waters, because we are trying to save which is a basic human basic need for human life. So if we can come with a way of making sure that the little water that we have, we conserve it for our people, and even try to find secondary sources of water, like polishing the treated wastewater, I think would have saved human livelihood, and maybe come up with another initiative, maybe of trying to reintroduce indigenous plants where they can grow. Because on the desert area, I think that one is another challenge that maybe I may not be in a position to answer that one. Thank you. I don't know whether that addresses your concern.
very much the presenters for good presentation and also for being able to respond amicably to questions which were directed to you. I would like to take this opportunity to invite the chair for the next part of the session. You are welcome.
Thank you very much to all the presenters, and please a big applause to Professor Hamisi Malebo for moderating during all this afternoon. Thank you very much. So now we can say that you are free from this room, but not totally free, because you are invited to see the poster presentations. It's a kind of talent exhibitions during 1 hour. After that, you will appreciate a Tunisian culture experience, which is a kind of traditional band from here, from Tunisia. In the same time, you will take your dinner. So enjoy. Thank you very much. Excuse me, maybe there is another information.
Yes.
Yeah?
Yes. All right, thank you so much. I remember you liked me so much. I was the most loved person when I said that we were going for the poster session and some whining. And then later, I became the most hated person when I had to bring you back into the room. So we have come to that poster session now. As I said, the posters are out there directly opposite this hall. When you go out, please do your best to visit every poster. I said that we have judges in the house. They are amongst us. We have selected them. You will not know them until they have judged. On the final day, we will announce to you the winners and we'll announce to you your judges. Take the opportunity to view the posters. You can also have a drink now. That drink I announced a bit earlier. Now you can have it as you do the posters. As our MC has said, there is a bit of cultural dancing and a bit of culture of Tunisia to show. That will come a bit later as we finish from the poster and then have dinner. All right? If I have spoken to you about being a judge, I have the document for you for being the judge. I will also explain to you what we want from you secretly so that the presenters will not know what we are looking for. We will announce to them how we judge at the end of the day. Thank you very much. Bless you for giving us your time. Thank you very much.
Were you looking for me, Boniface?